packaged with all app resources can't be packaged within an app. Resources today are too large. They take up too much room. Designs might need to change. We have too much dynamic data. We just can't load everything into the app. A perfect example of this is social media. Social media is continuously dynamic. And if people on, say, Instagram are posting new images, there's obviously no way for us to package those with our app. So we have to be able to load those images into our app and display them efficiently. Now, thankfully, again, in the world of Android, we have multiple open source libraries to help us do this. The three kind of most popular examples I've run into include Glide, Picasso, and a more recent one specific to Kotlin called Coil. So we're going to actually be using Coil this week because I think it has the easiest setup. And really, this is all we need to do to get a basic implementation of loading an image from a remote URL. Now, Coil and all of these image loading libraries can do other things like specifying placeholders, specifying animations between the placeholder and the loaded image, and error icons, and all that kind of fancy stuff. But for us this week, all we need to focus on is this functionality right here. We're going to build up a URL to get the icon for each of the forecast weather icons. And then we're going to pass it into this call and load that icon into an image view in our list items. Now time to jump over to Android Studio, and we will start work on our week 7 assignment demo. Okay, now that we're back here in Android Studio, we're going to first start off by updating how we pass the saved zip code to our different fragments. And to do that, we are going to implement a means of saving the zip code when we enter that zip code into our location entry fragment. So the first thing we're going to do is come to the left-hand side of our screen. And we're going to navigate down to our package where our code resides. And we are going to right-click on our package name, go to New, Kotlin File or Class. We're going to create a new class called Location Repository, and then hit Enter. Saving of the zip code, we're going to use shared preferences once again. So to do that, we will first need to make sure that our class takes a reference to a context, because as you remember from our previous implementation with shared preferences, you need a context to get access to the shared preferences. Next, we're going to create a property to store those preferences. So we'll type private val preferences equals context dot get shared preferences. We'll pass in settings for the file name once again, and we'll pass in context.mode private. To represent different types of locations within our app. So to do that, we will come a couple lines above location repository. We'll type sealed class, and we'll name that sealed class location, and then we'll add the open and close curly braces. Now within that, we're going to add one specific implementation of this location type, and that's going to be a data class. Zip code type is going to take a single property, also called zip code, of type string. And then this class will extend the location class. So we've created this new sealed class hierarchy of location that enumerates all the different types of locations we handle in the app. And then we've added zip code as a specific type. Now for now, that's all we're going to have. But by the end of the course, we should also be able to support lat long locations as well, taken from the GPS. And so by implementing this now, it gives us room to grow into that added implementation down the line. So now we need a way to expose this saved location to other interested parties within our app. And so we're going to do this with live data like we've done with our other repositories. So we'll create a private val underscore saved location property of type mutable live data, which will give us a location. If you get the little red underline here, it'll just need to be an import. So you can put your cursor under the red class name and hit Alt Enter, and that should do the import for you. Once we've defined our property, we need to assign its value, and we will create a new mutable live data. And now, like we've done before, we want to create the publicly exposed version of this live data. So this time will be a public val saved location. Its type will be a live data of location. I'll import the live data class, and I will assign this to saved location. Implementations. This will let us change the saved location internally by referencing underscore saved location, and then external parties can observe the value of saved location. Anytime underscore saved location's value changes, saved location will also change. By having these two separate properties here, it prevents outside parties from manipulating the values stored by saved location within this class. We want to create a way to save the location when we get it from our location entry screen. So we're going to create a new method called fun save location, and that's going to take in one of our new location objects. So now we're going to do a when statement here, and we're going to pass location into this. We're going to say when location is location.zipcode. We want to save that location value by typing preferences.edit. This starts a new edit preference session. Put string key location location dot zip code location dot zip code, and then we'll hit a zip code, and then we'll hit apply. So what this will do is make sure that anytime we call save location, it's going to save that location to shared preferences. Now there's one small little update that I want to point out here that we could make. So here we have defined key zip code as an inline string literal. However, if we wanted to reuse this string anywhere, if we had to manually enter it every time, it would be error prone. There's a chance that we could change it without meaning to. So we're going to create a constant to store this. In Kotlin, you can create top level constants pretty easily. So we're going to come outside of our location repository class, but still within the same file. And we're going to type private const val key zip code equals key zip code. So what we've done here is we've defined a private top level property. So it's only available within this file, which is exactly what we want. It prevents other people from using it. We've defined this as a const because this value will not change. So at compile time, we know what this value will be up front. And then again, it's a val for the same reason, because we're going to assign this value once and it's never going to change. So now we can copy key zip code and use that down here in our save location method. Location. But we still need to know if that if that location changes so that we can notify other callers. And the reason this is important is because this location could change because other instances of this class maybe are going to change it, or maybe something on disk could even change it. So we want to listen for updates to that so we can notify our observers. Now there's a pretty easy way we can go about this. So we're going to come back into location repository. We're going to go kind of below our properties a little bit, and we're going to create what's called an init block. An init block is very similar to a constructor body. Basically, anything inside the init block will run when this class is created. And within this init block, we're going to add a shared preferences change listener so we can listen to changes in this value. So we'll type preferences dot register on shared preference change listener here. Now within our Lambda, we're going to have two parameters available to us. The first one is the shared preferences, and the second one is the key for the preference value. So for us, we want to check if key does not equal key zip code. We can go ahead and return from this Lambda listener. However, if it does equal key zip code, then we're going to go ahead and get access to that zip code. So we'll type val zip code equals preferences.get string key zip code. We will pass in a default value of just an empty string. We'll check if zip code does not equal null, and zip code dot is not blank our live data. So we'll say underscore save data. So we'll say underscore saved location dot value equals, and we will create a new instance of our zip code location class by typing location dot zip code and passing to the constructor that zip code value. So if we take just a closer look at this again, when our location repository class is created, the init block is going to be run. We will register a shared preference change listener so that anytime shared preferences change, we'll get notified. We only care about changes to the location setting right now. So if the key does not equal key zip code, we'll return and just ignore it. If it is the zip code key, then we will get the current zip code value. And if it's not null and it's not blank, meaning we actually have some saved data there, we will go ahead and forward that on to our saved location observers. There's one other small change that we need to make here. Our listener notify our observers of whatever the current value is here. So one easy way of going about this would be to once again get the current zip code value. So here I've done a copy and paste, and again I've defined a zip code variable, and I've gotten that value. And then also once again, we could do the same checks. If zip code does not equal null and it's not blank, go ahead and notify our saved location live data. We are now duplicating that logic in a couple places. So let's clean that logic in a couple places. So let's clean that up a little bit. We'll come down to the bottom of our class, and we're going to create a new private method by typing private fun, and we're going to call this broadcast saved zip code. And then one more time, we're going to do a copy, a delete, and then a paste into this new broadcast saved zip code method. And then back up in our init block, we will call broadcast save zip code at the end of the init block so that we send off that initial value. And then within our preference, shared preference change listener, we can also replace it and pass in broadcast save zip code. So now our init block is much smaller, and we've consolidated this logic within broadcast save zip code. So now when we create an instance of location repository, it will look up the current value of the save zip code, broadcast that zip code if there is one, and it will listen to future changes in that zip code. Now we're ready to actually use this location repository. And so to do that, we're going to open up location entry fragment. At the top of location entry fragment, we are going to create a new property for a location repository. So type private location repository latenit var location repository. There we go. Our on create view, we will go ahead and create our instance of location repository. So we can type location repository equals, and we'll create a new instance of location repository and pass in context using the require context method. Then in the enter button, navigate up call. Before the navigate up call, we can type location repository, save location, and we will create a new instance of the zip code location class. So location dot, there we go. So I typed location. Now it's asking me to import that location class. Now I can go ahead and type zip code and pass in the zip code string that we had previously. So now anytime we enter a new zip code, we're going to save that in our location repository. Now we want to open up current forecast fragment, a reference to a location repository, So we will do private latenit var location repository. And down towards the bottom of our location repository class here, in repository, by saying location repository equals location repository, and once again we'll pass in require context to make sure we have that context at runtime. Changes to the location. And so to do that, we're going to first create an observer by typing val saved location observer equals observer of location. We're going to create a lambda, and the parameter name will be save location. When saved location, within this when statement, we can type is location code, and then we will, anytime we get a zip code, we will type forecast repository dot load forecast location dot zip code. For our lifecycle owner, we will pass in view lifecycle owner. We will pass in view lifecycle owner, and we will pass in our saved location observer. And so now, if we look right below that, previously when we were loading the forecast as soon as the class or as soon as our view is inflated, we no longer want to do that. So we will remove that. So now, when we create current forecast fragment, we are going to listen for changes in the saved location value. And anytime we get an update in the location, we will refresh our UI. All right, now that we have updated current forecast fragment to take in the current saved location, let's update our weekly forecast fragment. So we're going to start by just closing out all these files. And then we're going to open up create a new private latent property for our location repository. So we'll type private latent var location repository. Very similarly to before, we'll come down and remove this old call to forecast repository.load forecast, because we're going to update this to respond only to changes in the location. So let's start by initializing location repository. Location repository, we'll pass in required context. So we'll call it val saved location observer, saved location observer equals observer of type location, and we'll pass in a lambda. Saved location, so it's more readable than just using it. And again, we'll use a when expression here. When saved location is location.zipcode, call forecast repository dot load forecast, and we're gonna pass in saved location dot zip code. The reason we keep using when expressions here is because when expressions can enforce that you handle all types within a sealed class hierarchy. So by using when expressions, it helps us in the future if we start adding different types of location we want to handle, because it'll enforce that we actually handle those locations in these when expressions. Now, below our observer, we need to actually observe the value. So we will type location repository dot saved location dot observe. We'll pass in view lifecycle owner and our observer. So just like current forecast fragment, weekly forecast fragment will now refresh its UI anytime the saved location changes. So now, as we start thinking about moving more and more towards loading real data, we're going to need to refactor our forecast repository. So I'll close weekly forecast fragment, and I'm going to open up forecast repository. In forecast repository, we currently just have one main method. We can just load a generic forecast. So we're going to want to update this to be able to differentiate between the current forecast and the weekly forecast. And so we're going to do this very similarly to how we've done before. So just like we have this live data for weekly forecast, we're going to create one for a current forecast. So we'll type private val underscore current forecast equals mutable live data of type daily forecast. Pass a daily forecast value to observers, And now we will create the public to observers. And now we will create the public version, which is val current forecast of type live data daily forecast equals underscore current forecast. Our load forecast is currently loading 7 values. So that really is currently loading 7 values. So that really is kind of mimicking the weekly forecast behavior that we want in the end. So we're actually going to rename this method to load weekly forecast. Typing fun and calling it load and calling it load current forecast. They're going to generate one random daily forecast item. So we'll type val generate one random daily forecast item. So we'll type val random temp equals random dot next float 100 times 100. So remember, this will give us a random value between 0 and 100. And then now we'll type val forecast equals daily forecast. We'll pass in a new random date. We'll pass in our random temp, and we'll call get temp description, and again pass in random temp. Our live data. There we go. We have separate methods for loading the weekly forecast and for loading the current forecast. So we're going to need to update our fragments then to account for these new methods. So first, let's open up weekly forecast fragment. So you see here, when we try to call load forecast, we are getting an error. So instead of load forecast, we're going to type load weekly forecast. And that should be pretty much it. We didn't really change anything else with this method for weekly forecast. Now let's open up a current forecast fragment. Here we actually have changed a little bit more. Add a weekly forecast observer. We now really want to update this to just forecast observer. We now really want to update this to just be a current forecast observer. So we're going to delete this current observer code, and we're going to update it for the new method. So we'll create a new observer first, and we'll call it current forecast observer equals an observer of type daily forecast. Within our Lambda, we will name the parameter forecast item adapter, and then we're going to type daily forecast adapter dot, and then we're going to type daily forecast adapter dot submit list of forecast item. So basically our adapter expects a list right now, and we don't want to update our adapter quite yet. So we're going to take in our single forecast item for the current weather and just create a list out of it. And it'll just be a list of type 1. So our UI won't need to scroll or anything. Now, once we've created our observer, we can type forecast repository dot current forecast dot observe. We'll pass in view lifecycle owner and our current forecast observer. And then down below in our saved location observer, whenever we get a saved location, instead of calling load forecast, we want to call load current forecast. This is because in our load current forecast method, we didn't pass in the string yet because we're not really using it, but we are going to eventually. So we're going to come back to load current forecast and just go ahead and add a property called zip code of type string. So now if we go back to current forecast fragment, we should see that our call to load current forecast fragment is correct. So now let's just check on what the app looks like at this point. We'll go ahead and click run. And shortly, we should see here that we now have a current forecast fragment that shows one item and a weekly that shows several. This is expected because we have no saved location yet. So now let's go ahead and enter a location 1, 2, 3, 4, 5. We'll click submit. And now on the current weather screen, we see one item. And on the weekly screen, we see multiple items. And now if we close this and rerun it, this time we immediately see data because our location repository saved that data and then immediately served it out to us when we started the app up again. So this is one reason why this repository pattern is really helpful to us. We can save out the data, we can manage how data is returned, and we can do things like respond with cached data as soon as the class is loaded. And then if we wanted to, we could load new, fresher data in the background and respond when that data comes back. So it lets our UI be more responsive and even can really help us build offline first UIs and applications that don't need any type of internet connection. Update it. And we are also now using different repository methods to load our current forecast and our weekly forecast. Now it's time for us to actually start loading real data using the Open Weather Map API. So what we need to do now is go to Chrome and go to your search window and search for Open Weather Map API. weathermap.org. Go ahead and click on that. And it should bring you, to the API page here. If it doesn't, it should be at openweathermap.org/API. Now, as we mentioned earlier in the lecture, these are all different endpoints available from the Open Weather Map API. And now to use any of these, although there's a lot of functionality for free, you do need to create an account. So first, go up to the sign in page in the upper right here, click sign in. If you don't have an account, you can click create an account, an email, and then a password, and then a couple privacy GDPR type things here. Go ahead and fill this out and create your account. And then after a few minutes, you should get an email asking you to confirm your account. So once you've confirmed your account, you'll want to come back to the sign in page and go ahead and sign in. If it prompts you for any of this, just go ahead and click cancel. And so then it should send a confirmation. And like I said, you check your email, look for the confirmation. So the important thing here then is to come to API keys. Now, typically you don't want to share your API keys. As this is just a demo, I will have to make sure and go back and delete this key later. But this key right here is what you will use to authenticate your application with the API. So this is essentially kind of your unique identity to the API. And it's how they will monitor what functionality you have access to and how many network requests you can make. So if you want to test out that your API key is working, go ahead and just copy it. Then come back over here to API, go to the current weather section, click on the API doc. Now you'll see that it has some sample requests here. So we could grab one of these sample requests, and we'll grab this sample request for a zip code API to load the weather. And we're just going to request for a zip code API to load the weather. And we're just going to create a new tab, and we're going to drop that into the tab for now. We're not going to hit enter. We're then going to go back to our API key. We're going to grab our API key. Now we're going to come back over to our other tab, and we're going to paste our API key at the end of this URL after the API key query parameter. And then we're just going to delete the country code query parameter. And for a zip code, I'll enter a Seattle zip code of 98119. And now, if I hit enter, you probably will see something like this. This is going to say invalid API key. And the problem here is that it takes a little bit of time for your API key to become valid. Now, what can you do about this? There's not a whole lot you can do. What you'll have to do is just wait. Hopefully it doesn't take very much time. But once you do sort of get the valid API key and it's authenticated, initialized with their system, the way you'll be able to tell is that this will return a valid response. So I will now switch to a different API key that I already have prepared. And now this time, when I hit enter, we'll see that I get this big block of JSON back. Now, if you want to actually visualize this a little bit more easily, we can just copy this JSON response. I'll open a new tab, and I'm just going to type JSON viewer. And I often just use this first option here, online JSON viewer. I'll click on that, paste that into this text tab, and then I'll look at this viewer tab. And so this is what the response looks like when we use that current weather endpoint. We can see that it hands us back coordinates that include a lat long location. We get this list of weather objects back that tell us it's rainy with moderate rain. We get this main object that includes temperature, the feels like, the min max. Notice by default that comes back in Kelvin. We can specify the units for Celsius or imperial if we want to get Fahrenheit back. So this basic workflow of looking at the API, looking through the API documentation here, copying a call, pasting it into a tab to test it out with the parameters you need, and then inspecting the response, that's a pretty common workflow, and that's a good way for us to get started. So if you're having questions on what the response should be, you can do this, or you can look at the API documentation, and they should also have sample responses for you to take a look at. Okay, now that we've explored the endpoint a little bit, let's close these tabs. And now we want to take a look at retrofit, because we want to start integrating a retrofit so we can actually use these endpoints. So go to your search tab and just type for Android retrofit. And you should see square.github.io, retrofit Square open source. So we're just going to click on that real quick, just to highlight that this is the retrofit page. And there's a great little intro here and some API documentation to give you a great second resource here for how to start integrating retrofit into your application. So in particular, I'm gonna scroll down to the bottom here, and you'll see that it gives you an example, a Gradle implementation for how to pull that into your build.gradle file. It just will ask you to insert the latest version. So I'm going to copy that, and then we're going to go back over to Android Studio. Or scroll to the bottom down here in the left, go to app build.gradle. To the bottom down here in the left, go to app build.gradle. paste in this dependency that we just grabbed from the retrofit documentation. Now I already looked this up before, and version 2.8 version of retrofit for us to use. Now that's the base retrofit implement for us to use. There's one other dependency that we want to pull in right now. So I'm going to type in again, implementation, called converter-mashi. So this time we'll type converter-mashi. So this time we'll type com dot square up dot retrofit2 colon converter dash mashi colon, and this is version 2.5.0. So this Mashi converter is going to help convert our JSON responses into nice Kotlin idiomatic data classes for us. Once we've done this, let's just do a quick Gradle sync to double check that these dependencies have been declared correctly. It looks like that all worked. So now there's two other little configuration things we want to do before we start implementing our retrofit endpoint. So we want to go to the left-hand screen over into the project pane again and open up the Android manifest XML file. And we need to do two things. We need to add a permission. Now we haven't talked much about permissions. Permissions basically tell the system that the user has granted this app permission to access certain functionality. So in this case, we want to add a permission for using the internet. So to do this, we're going to type an angle bracket, and you should start to auto-populate the options for you. So in this case, we see this uses permission tag. I'm going to hit enter. And then again, immediately, it's going to suggest that I use the android.permission.internet permission. And then I'll just close out that XML tag. So by adding this, uses dash permission, Android colon name equals android.permission.internet, we've declared that this app will use the internet permission. Now we'll talk more about the permissions model in a future lecture, but by default, this permission will be automatically granted. There's kind of what's known as sort of standard permissions and then unsafe permissions. Unsafe permissions need to be requested. Standard ones like internet are just kind of granted by default. If we hadn't have added this permission, then the first time we tried to access the internet, our app would have crashed and it would have said, hey, you don't have the internet permission. So I've saved us that crash. Trust me, I do it all the time. I always forget this. So hopefully you can learn from my mistakes and add the internet permission. The next thing that we need to do is add, go down to our application tag here. And we're going to add a new line here. Uses clear text traffic. And we're going to set that value to true. Basically, this is a security thing where newer versions of Android want you to try and use secure HTTPS traffic anytime possible. This is a good idea. However, for our process, we are not going to be worried about that right now, and it's outside the scope of this course. So by adding uses clear text traffic, we won't run into any issues. We've added the retrofit dependency, we've updated our permissions, we've updated clear text traffic. Now it's time to finally start integrating retrofit into our app. So let's go ahead and close these files. I'm going to right click on my package, here, com goobar.io 8340. And I'm going to go up to new and select new package. And I'm going to name this package API and hit OK. Now I'm going to right click on that new API package and go to new Kotlin file or class. I'm going to select interface and I'm going to type open weather map service and hit enter. So now by default, this should create a new Kotlin interface called Open Weather Map Service. And this is going to serve as the basis for our retrofit API service. Before we create our first interface, or our first method on the interface, excuse me, a valid implementation of this interface. So this will be the actual valid implementation of this interface. So this will be the actual service implementation that we will use to load our data. So to do that, we're going to create a top level function in this same file here. I'll type fun service, and it is going to return an instance of our interface. So I'll type open weather map service here, and then add my block body. Within this, I'm going to create an instance of the retrofit builder. So I'll type val retrofit equals retrofit dot builder. If it asks you to import retrofit, go ahead and do that. By the base URL for this retrofit endpoint. So this should equate to the base URL of whatever API service you're using. So for us, that base URL is going to be http://api.openweathermap.org. So that will give us a created retrofit object. And now we can use that to create our service implementation. So we will return retrofit.create weather map service class.java. An implementation of our API, and we'll be able to use that API class to actually return the weather data. So let's go ahead and get started then on implementing our service. To start, we're going to come back over to API on the project pane, create a new Kotlin file, and we're just going to call this file. Now within this, we are going to define the models needed to model the API response from the weather endpoint at Open Weather Map API. So to do this, follow along here. We're going to create a data class called forecast that will hold a temp value, and that temp value will be a float. So this is going to hold temperatures for us. We're going to create another data class called coordinates. This is going to hold the lat-long coordinates, which will be important because we will need those when we're using the one-call API for the 7-day forecast. So this coordinates class will take a val called lat of type float and a val called lon of type float. So this will hold our lat-long coordinates. This time it's going to be called current weather. String. This name is going to be the name of the location that was passed in, which is a little counterintuitive, but it'll help us display the name of the location in the current weather screen. Then we're going to make use of our coordinates class. So we're going to create a property called coord, which is short for coordinates, and it's going to be of type coordinates. This one's going to be a little bit trickier. We're going to define a property called val forecast of type forecast. However, the API response for this class does not have a forecast property. Its name is actually something very odd, that it's named main, but within that main object, it has things like the temperature. So in cases like this, where you want to have an API and properties that are named more semantically correct or just more intuitively on the client side, we can annotate this property so that Retrofit knows how to parse it, but we can call it whatever we want. So to do that, we're going to type at field, which will apply this annotation to this field alone, colon, JSON, and then we're going to say name equals main. And then if it prompts you, go ahead and import the JSON annotation. So now what this is saying is that there is going to be a JSON response field called main, and we want to map that into this forecast property. So now that we have our API model defined, we're going to go back over to our Open Weather Map service. And now we can go ahead and define the first method on this service, which will correspond to the Open Weather Map /weather API. Point method. We'll start off by defining the get annotation to specify that this is going to be a get REST request. So within this get annotation, we're going to define the path to the endpoint that we want to use. And the way that these will get built up is it'll take the base URL that we defined above, which was api.openweathermap.org, and then it's going to add this bit for each individual endpoint. So for this endpoint, we're going to use /data/2.5/weather. And a method as we normally would. So we'll type fun. We'll call it current weather. What parameters we want to include along with this method. These should map to the query parameters that we were using in our browser and that are present in the documentation. So the first query parameter will be the zip code. So we're going to use the @query annotation here. And within the request that's going out to the endpoint, we want this to be called zip. So we'll pass zip in as within the query annotation. And now we need to define the name of the parameter, and we can call this parameter anything we want on the client side. So we'll call it zip code, and it'll be a type string. Here, we're going to do at query units. This will allow us to specify what units we want it back, because we probably don't want it in Kelvin all the time. And I'll just call this parameter units, and it'll be a type string. And then the last parameter, it needs to be the app ID, which is that API key that we got when we created our Open Weather Map account. So this time again, at query app ID, and we're going to call this API key, and again it is of type string. Now we need to specify the return type. So this has so far specified the request. Now we want to define how the response will come back. So we're going to use that retrofit call class to wrap this response. So we'll define call, and then we need to tell it what type to expect back. And so we want to expect back one of our current weather models. So now when we call this method, we should be able to actually get back valid weather data for the zip code that's passed in. So now let's go make use of this. Let's open up our forecast repository, and then we're going to go to load current forecast here. And we're just going to delete everything that we have there currently. Kick this off by creating a call class that represents that request to the endpoint we want. Create open weather map service dot current weather. We will pass in the zip code. Eventually, actually, then we will pass in the units here. And these units, for now, I want to use Fahrenheit, so I will pass in imperial. Pass in our API key. So I'm just going to put API key here for now. Back. Well, as we saw in the lecture notes previously, we can type call.enqueue, and then we need to pass a callback in here. So we're going to basically create an anonymous inner class here. So this will be an implementation of the callback without any actual name. It'll be used just in this location. To do that, we'll type object : callback. Prompt you for importing what callback you want to do. We want to make sure that we use the retrofit version of this callback. As you can see here, there are a lot of different callbacks available. The retrofit one on my screen is at the very, very bottom of this list. So I'll make sure I import the proper retrofit callback. Hand us back a current weather. So we'll put that within the braces. And then I'm going to add my open and closed curly braces here. And now when you get this, you should see a little red underline underneath the object. Basically, this is indicating, hey, you have not implemented all the methods we need. So to fix that, you can put your cursor on the object with the underline and hit Alt Enter. And it should ask you if you want to implement the members. And you can hit Enter. And then you can highlight both methods and hit OK. And it will generate the implementations of the onFailure and the onResponse. Now we can handle both of these cases. So for now, if we get a failure, I'm just going to log it. So I'm going to type log.e. Log.e will be use the default Android logger to just log that issue locally. For my tag, I'm just going to pass in forecast repository : class.java.simplename. And I'm going to just pass a message of error loading current weather. And then I will pass along the throwable. So this will give me a little bit of information to start debugging if we have any problem here. Now the more interesting case is in onResponse. So this is the case where theoretically things have been loaded correctly for us. So let's go ahead and think about how we can handle this. So I'm going to type val. And then we'll use the response body dot body. And then we'll use the response body dot body dot body. That dot body call will essentially unwrap it from the response call. At this point, we can check if that is null or not. So we can say if weather response does not equal null, then we could update our current forecast data. You might see a little bit of an issue here. We have current forecast, which is expecting a daily forecast, but we have our weather response, which is a current weather object. So we need to come back up to the top of our repository and update current forecast to take in that new current weather model that we defined. So here where it says current forecast, let's update this to underscore current weather. property as well to say current weather. So if we scroll back down here now to onResponse and we update this to _current weather, now everything in our repository looks good. Let's just jump over then to forecast fragment and double check everything here as well. And sure enough, we see that we have an issue here, which is that the forecast repository.current forecast is not available anymore. So if we update this to say current weather, we'll then see we have yet another issue. And ultimately what's going to happen here is we're going to need to update our adapter as well to account for this new data. So for now, we're just going to let this error sit, and we're going to go back over to our forecast repository. Now, if you remember correctly, if we look at our call class here, or excuse me, our call statement here, we passed in a temporary string for our API key. So now we're going to actually define our API key, and then we're going to update our project so that we can use our key without having to check it into our GitHub repo. And the reason we're doing that is because your API keys are meant to be private. You don't want to share them like I'm doing here in this demo with all of you, because theoretically you open yourself up for someone using your key when they shouldn't be. So for us, what we're going to do is we're going to come to our left-hand side of the screen here, again in our project pane, and we should have at the very bottom a local.properties file. If you don't see local.properties in your project, go ahead and create it. To create it, you would simply go to the root directory of your project, right-click, go to New File, and you could enter in local.properties. Within this local.properties file, we're basically going to create a new build configuration property called open weather map open weather map API key. And then I have placed in my API key right here. So what this will let us do is pull this value in from our Gradle file and use it at compile time so that we can get access to that. And by default, this local.properties file should not be checked in to your project on GitHub. In fact, if you look in the .gitignore file, which Android Studio should have created for you, we should see that it is explicitly ignoring the local.properties file. So it makes it perfect for this use case. So within your local.properties, add this open weather map API key property name and pass in your API key. Then we're going to open up our app build.gradle file. We're going to come up here to the default config block. And we want to add a property for configuring this API key property. Now, the first thing we need to do is go to the very top of the Android block, and we're going to type def local properties equals new properties. The next line, we're going to type local properties dot load new file input stream dot file properties. Basically created this new local properties variable, and it's going to load any information in from that local.properties file that we just used. And now, just as a side note, this build.gradle file The code we just wrote probably seems very familiar if you're used to Java. This language that's used for Gradle files is actually called Groovy. So technically this is a whole separate programming language that we just used. So now within just this one Android project, you can say that you have worked with JSON, Kotlin, XML, and Groovy. So that's pretty cool. It's 4 languages in one project. So now once we've defined this local properties configuration, now we'll come back down to the default config block and we're going to make use of that. So we're going to define a new configuration property by typing build config field. This will let us define a new field on our build config class. It's going to be of type string, weather map API key, map API key, a string substitution to pull that file in and parse it correctly. Substitution to pull that file in and parse it correctly. So to do that, first we're gonna type double quotes, and then I'm going to do a backslash double quote. So that has escaped the quote, so it should make it into the final string. And then now I'm going to do a dollar and then open and close curly braces. So now this is going to do a string substitution within this. And now out on the other side of those brackets, we're going to do another backslash double quote just to finish escaping that. So now everything should be even on both sides, and we can worry about implementing what's within these curly braces. So within the curly braces, we're going to type local properties. We're going to do open and closed brackets, and we're going to pass in the same key name that we used in the local.properties file. So open weather map. So now once we've finished adding this build config field, we should be able to do a git sync again just to make sure it regenerates the property. Then we can come back over to forecast repository, and where the API key used to be, we'll type build config.openWeatherMap API key. And so that's going to bring that API key in for us and allow us to pass that along to our API requests correctly. So now it's time to go ahead and update our UI to account for this new current weather object. So we'll go back to current forecast fragment. And I go into the layout XML, the list from the layout. We'll find this from the layout. We'll find this recycler view here, and we're going to remove that. If we go back to the design view, we'll see here that all we have now is the floating action button. So now what we're going to do is just come over here and drag a text view into our layout. I'm going to constrain it to the top and left. We'll just add a quick 16 dp margin to the left and top as well. Location name. And then if you really wanted to, you could come lower in the attributes panel and maybe update the text appearance to something like large. So now we'll go back over to current forecast fragment, and we're going to update our repository interaction here. So let's start by looking at our observer. We're going to update this to be current weather observer. Instead of a daily forecast, it's going to pass us back a current weather object. Adapter, we're going to we're going to type location name dot text equals weather dot name. Now, you might notice we don't have a location name property yet. So we need to go back and update our view properties here. So first, we'll notice we have this daily forecast list, the layout manager and adapter. All of that stuff can go now. Location name text view equals view name text view equals view find view by ID r.id dot location name. And now back down in our observer, location name resolves correctly. Current weather dot observe, and we will pass in our current weather, observer. So again, just to review, forecast repository dot current weather is a live data. It hands out current weather values anytime we have loaded that new data. When we get a new current weather object, we're going to update this text view to show the name of the location we just loaded weather for. Let's go back over to fragment underscore current underscore forecast. So if we click on this text view, we're going to work on cleaning this UI up a little bit so we can display more information about the current forecast. So here, we're going to come over to the right, and in the common attributes section, under the tools text icon, that's the one with the little wrench by it, I'm going to just type Seattle here, since this is going to show our location. And then under the regular text property, I'm just going to delete that for now. Another new text view. This one I'm going to name temp text. It is right along there with the location name. Temp text property val temp text colon val temp text colon text view equals view dot find view by ID r.id dot temp text, our current weather observer, and we'll type temp text dot text equals format temp for display, and we will pass in weather dot forecast dot temp, comma, display settings manager dot get temp display setting. So let's just one more time quickly review. When current forecast fragment is created, it is going to listen for changes in the saved location. Anytime the saved location is updated, it's going to make a call to forecast repository.load current forecast and pass along the saved zip code. When the repository returns its data, we're going to update the UI to display the location name and the temperature. So let's go ahead and try to run this and see how our UI looks now. So I'll click run, and then I'll just open up my emulator here. Likely we'll see a crash immediately. The reason for this crash is because we have updated the permissions, and we are now actually making network requests. We have internet permission. So the easy way to fix this is to just make sure you delete your app once before you try and actually load real data for the first time. Back and redeploy the app. And so you see now here, we've redeployed the app. you can see that we have this empty text view property here. So let's go back to Android Studio real quickly and just fix that. So go to our current forecast fragment. We'll click on text view. We're going to make the default text be blank, and the sample text, we're going to make it say something like 72.0. There we go. So now we have a good idea of what our UI will look like, but it won't display. Now we have a good idea of what our UI will look like, but it won't display on the screen. Once again, let's rerun this. We'll switch over to our emulator. And there we go. Nice blank screen. And again, we don't have a saved location yet, so all these screens are blank. So now let's go ahead and enter 98119 for Seattle zip code here. Click submit. And once again, we'll see an error here. So now on this error, if you come into your logcat and you find the error, you should see something that looks pretty similar to this. If we make this a little bit bigger here, should see something that looks like unable to create converter for class current weather. So now what this is telling us is that our retrofit instance here, this implementation of our API service, doesn't know how to convert the JSON response into our Kotlin classes. So this is where that Moshi converter comes into place. So we'll come right below base URL here and type add converter factory, and then we'll pass in Moshi converter factory.create. Now, once you've done this, go ahead and do a rebuild on the project. And then once that's done, go ahead and redeploy. And then we'll switch back to our emulator. Now we see that we are having Seattle displayed out to the screen and real temperature data. So this is the first instance in our course so far of actually loading real live data from an API out there in the wild. Back over to Android Studio. Loading our weekly forecast data. So let's just clean this all up a little. Forecast data. So let's just clean this all up a little bit. Close all the files. And we're going to start by cleaning up our current daily forecast class here. We're basically going to create a new proper version of this class. So for now, we'll right click on that. We'll click delete. We're going to click unsafe delete here because we know there's other places in the code currently using this, and we'll update those later. So we're just going to hit OK. So now we've gone ahead and deleted daily forecast. We're going to come up here to our API, package again. Right click on this, go to new, Kotlin file, and we are going to create a class, or we will name the class or file weekly. And like we did for the current weather, we're going to define several new models that will build up the response for our weekly forecast data. So the first one will be called data. It's going to have a main property called string, a main property called string, description property of type string, and it's going to have an icon property of type string. Class. This is going to have a min property of type float, and a max property of type float. data class daily forecast class daily forecast property of type long, but because the JSON response names it differently, we need to once again use @field: JSON equals DT. So in this case, DT stands for date time, but we want to refer to that property as date because it's more specific. Then we'll define another property here called temp. That'll be an instance of the temp class we just created. And then finally, val weather, which will be a list of the weather description classes that we just created. And finally, the very last thing, we will create a data class called weekly forecast, which will take a list. Now this weekly forecast object will be the response for our weekly forecast object will be the response for our weekly forecast endpoint. So like we did before, let's now go to forecast repository, and we will update our live data to account for these new API models. So now instead of a list of daily forecast, our live data will return a weekly forecast. So now let's scroll down to our current load weekly forecast implementation. And we're just going to delete all of that because we are going to be updating that very shortly. Now, before we go ahead and implement this method, we're going to update our UI to account for this new weekly forecast item. The list items that we have for our weekly forecast list. And we're going to select item daily forecast. Excuse me. And the first thing we're going to want to do here is add a new text view. This text view is going to take the date for each individual daily forecast item. So we're going to give this the ID over here in the attributes pane, and its ID is going to be date text. We will constrain this so that it sits to the left, just like, or right to the left of the temperature there. Text view. And we're going to come to the right hand side and we're going to delete its constraint on the bottom of the parent, because we want to update these so that they're nice and centered. Constrain it to the bottom of the parent. We're then going to select both of them, right click, go to chains, and click create vertical chain. So now what that's going to do is kind of nicely, evenly space them out here in that list item. Forecast list adapter. And we have several issues here that we want to fix. We need to update the import for daily forecast because we deleted the old one. So just put your cursor on daily forecast and hit Alt Enter and click import. And so that should fix a number of the issues. We want to come to the forecast view holder, and we want to add a reference to the new date text property and then update how we're binding that data to the UI. So to start, we'll come down here below description text and type private val date text equals view dot find view by ID in the brackets, and then we'll pass r dot ID dot date text as, and then we'll pass r.id.dateText as the ID. Down here in our bind method. So we no longer can pass dailyforecast.temp. What we need to do is type dailyforecast.temp. Now our temperature text will be updated properly. Description text, we're going to use dailyforecast.weather, 0 element from that weather list, and then we're going to pass in the description. So we will get the first weather description, and we should always have at least one, and we'll pass that description into our text view. And then finally, the new date text here. Text equals, and then we're going to want to format this text in some way that is understandable and meaningful to the users. And one way that we can go about doing that is to use a date format. So we're just going to scroll up to the top of the file here, and I'm going to define a date format that we can use to format dates into something we can read easily. So I'm going to type private val date format equals simple date format. Simple date format is a common Java class for formatting dates. And here we've passed in a pattern that says we want our dates to be formatted so that we see the month, the date, and then the year. Stamps that we're getting back from the API. So we'll type the API. So we'll type dateText.text equals date format dot format. And then we need to pass in a date object. So we will create a new date object. And when you import this, make sure you import a java.util date instead of java.sql date. So here we have created our new date. And what we want to do is pass in dailyforecast.date. And then there's one little caveat here. The date class expects this to come back in milliseconds, and the API is giving us back seconds. So we're just going to multiply this by 1,000, and that'll make sure that our date is going to display properly in the UI. Forecast fragment and update our UI here. Fragment and update our UI here. And so again, we're not doing a list of daily forecast items anymore. We're getting a weekly forecast item back. So we'll update our observer. Get to that. We're going to rename forecast items to weekly forecast. Just name forecast items to weekly forecast, just so it's a little bit more clear. And now we'll pass in weekly forecast.daily. And that'll pass in that list of the daily forecast items to our adapter. And now, also, just while we're here, we see our call to weekly forecast.observe, and we're passing in this. If you still have a this there, you might see this little warning that says use view lifecycle owner instead. So while we see this here, we'll just update that to say view lifecycle owner. It's a nice little hint there from Android Studio for us. Details, we also are going to want to update how we are passing this data in. So again, let's update the import for daily forecast. And then now we're going to need to update how we're getting the temperature and the description. So let's create a new property for the temperature. So we'll say val temp equals forecast.max, and we'll say val description equals forecast.weather brackets 0 to get the 0th element of that array dot, dot description. Now we'll come back down here to our call to the action, and we'll just pass in the temp and the description. We go back into our forecast repository, and we want to update the implementation of load weekly forecast. And before we can do that, we need to add the new method to our retrofit endpoint. So we'll open up open weather map service one more time here. And now below our first method, we are going to create a new method here. So again, we'll type at get. This time the endpoint will be /data /2.5/1 call. Function 7-day forecast. And now it's going to take a number of parameters. So the first one will be at query float at query lon float. Next up, we need to define a property called exclude as well, and that is going to be of type string. And since these are the same as our previous query, I'm just going to copy and paste these to save a little bit of time. Actually have the proper types. I see here I have a typo. I need this to be exclude instead of exclude. So there we go, I've updated that. So now in our forecast repository, new call. Now, if we go back to the newly implemented method for a second, you might notice that it doesn't take a zip code. It takes a lat long. This is just a limitation of the free endpoints on this, but it's actually a good learning opportunity for us because we're going to see how we can chain together two asynchronous calls. So what we're going to do is make a call to the current weather endpoint because it will return us back a lat long. We'll then use the lat long to call the second endpoint and get the 7-day forecast. So to start off, we'll type val call equals open weather map service dot current weather. We'll pass in a zip code, imperial for our units, and we'll pass in build units, and we'll pass in build config.openWeatherMap key. Just like before, we're gonna do the enqueue call. So I'm just going to copy and paste this to save a little bit of time. I will change the error message just in case we get an error. It'll be a little bit more descriptive. This time it's going to say error loading location for weekly forecast. So instead of updating the live data, we are going to load data. We are going to load 7-day forecast. So this will be val forecast call, equals service dot And this time we're going to say lat equals weather response dot equals weather response chord dot lawn, weather response chord dot lawn, and minutely hourly. So this endpoint actually can return you back current weather, minute by minute weather, hourly weather. We only want the 7-day forecast, so we exclude all of the rest of that stuff. To pass in imperial once again, and then of course one last time here for API key, we're going to use buildconfig.openWeatherMapKey. So we have that new large call created. Now we need to call enqueue on it. So forecast call dot call forecast 7-day forecast 7-day forecast dot enqueue. It's because we forgot the return type back here in Open Weather Map service. So we'll come back to our retrofit implementation interface here, and we'll make sure we have a return type here of call weekly forecast. So now if we come back here, we should be able to say forecast call dot enqueue object back of type weekly forecast. So this time on an error, we'll type log.e forecast repository class.java error forecast response equals response.body if weekly forecast response does not equal null, weekly forecast dot value equals weekly forecast response. So that will update our live data and ultimately update our UI when we have loaded that forecast. So now we will rerun this fragment. We see we have one more daily forecast import we need to update. Fragment. We're not showing a list of items. So we actually can't ever even get a list of items. To show forecast details anymore. So we're actually just going to remove show forecast details from current forecast fragment. An empty screen here on the week. So something is not quite going correctly here. So after some quick debugging, I found the issue in my code, which was another typo that I didn't notice before. But back in the Open Weather Map service, you need to make sure that the long property is LON, not LONG. So now we'll run this one more time. Weekly forecast data. And we see that our dates are nice and human readable and go out for the next 7 days or so. We're going to jump back over to Android Studio. And now we want to work on loading image data using Coil. So we'll jump over to Chrome one more time here. And we should see this coil-kt image loading for, coil-kt image loading for Android backed by Kotlin coroutines. So this is the image loading library we're going to use. And we can see here, it shows you right at the top the implementation line you need to add to your build.gradle file. So I'm going to copy that. And I'm going to open up my apps build.gradle file. Scroll down to the bottom below the retrofit dependencies and add that new dependency on Coil. Add an image to is the list items in our weekly forecast list. So let's open up item daily forecast. And I'm just going to close the rest of the files here. Whoops. Item. There we go. So we have item daily forecast open and nothing else. So what we want to do is add a new image view to this. You want the image view to sit on the left hand side of the screen. So what I want to do here is grab the temperature text view here, which is what my constraints are based off of. Delete that left constraint. Connected to it, they all move. So now that gives me room to add my image. Image view and drag it over. It's going to ask me to pick a resource. I'm going to type cloud, and I'm going to use this cloud image as the placeholder for now. And so you should see by default, it's going to be this nice little tiny cloud icon. So I'm going to click on that once again. In the attributes panel on the right hand side where it says ID, I'm going to update the ID to be forecast icon. And the layout height to be 56 dp so that it's much larger and fits the screen a little bit better. Then I'm going to constrain it to the left of the list item, to the top, and to the bottom. Then I'm going to give it 16 dp margin on the left, top, and bottom as well. And we should end up with this icon that is roughly centered vertically and is pushed over towards the left. Now I'm going to grab my temperature text view again, and I'm going to constrain it to that icon. And I'll just add some margin so that, again, things are nicely spaced out. Specifically, get a reference to this view and load the weather icon into this image view. So to do that, let's open up our daily forecast list adapter. I'm going to scroll up to the daily forecast view holder and create a new property for the image view. So private val forecast icon equals view dot find view by ID. This time it's going to be an image view, and so we'll likely need to import that for the first time. And for an ID, I'll pass r.id.forecast icon. So now we've got the icon. How do we load the URL into this? Well, if you remember from our weekly forecast model, we have this weather description. So anytime we have a weather description like cloudy or light rain, we get a description, and we also get an icon, and that icon is a simple identifier. If you actually look at the API documentation for Open Weather Map, you can actually see what this looks like. There is a section on icons. Let's find it here. API here. API documentation. There's a section here that says how to get icons. There's a section here that says how to get icons. If you click on that, it pulls you to this other page here. And it basically shows you that these day icons, these night icons, they all have this little 3-character ID essentially. This is what we get back in that icon property. So when we have that ID, we can basically place it into this predefined path and use that to load the image icon. So that's how we're going to load these icons using Coil into our image view. I'm going to start off by getting the icon ID out of that daily forecast item. So I'll type val icon ID equals daily forecast dot weather 0 dot icon. So I'm going to grab the first weather description, which is the primary weather description, and grab the icon ID. And then I'm going to type forecast icon, which is our image view, dot load, predefined string that the API uses for the icons. So that is HTTP API uses for the icons. So that is http://open weather map.org/img/wn/ and then we're going to do a string substitution here. So I'm going to do $ open and close curly brace, and I'll pass icon ID inside of those braces. So it's going to substitute in that code. And then to finish it off, I'll do @2x.png. So this is going to go to that URL, find that image, and load it into our image view. Nice looking icons there associated with the weather that it's displaying. Basically the simple process of how you load up an icon. Now, as part of the homework assignment for this week, you're going to be asked with loading the icon for the current weather string as well. And so the same process will apply. You're going to grab the weather icon if it's available. You're going to use that predefined URL, and you'll use Coil to load it into your image view in the same way. So check the assignment details for the more specific instructions about which screens and which icons you'll need to load. Now, one last thing before we end the demo for the week. As last week we were talking about material design, we talked about the app bar, we talked about our bottom navigation view. In regards to the app bar, we used a toolbar to basically serve as our app bar. And we kind of left it at that because we didn't want to complicate things too much. However, with that simplicity, there's one thing that we sort of missed, which is that the styling of this app bar isn't quite right. You'll notice the bottom navigation view has a little bit of shadow applied to it. And same thing with our floating action button. There's shadow there, there's elevation. Elevation is kind of a hallmark thing in material design. However, because of the way we implemented our toolbar so far, we don't have that shadow. It's just flat, and it's subtle. It might not even come across in the emulator here, but you likely notice it on your screens. So we're just going to make one more material design update to our app to continue making it look and feel like a modern Android application. So if we go back to Android Studio. We're going to go open up XML. And we see here we have our toolbar. And we don't have any type of elevation applied to this toolbar. Now we could explicitly add elevation to the toolbar, which would get largely the same effect. However, we'd have to manage that manually, and sometimes those rules can change a little bit. There is a default component that we could use that'll actually manage that elevation for us on its own, and we don't have to think about it. And it's actually conveniently called app bar layout. So that makes a lot of sense since it's representing our app bar. So to use the app bar layout, I'm just going to type an angle bracket and just start typing app bar layout. And it should automatically pop up for us. For the width, I'm just going to type match parent. For height, wrap content. Use app bar layout. I can add the toolbar inside of it. So I'm going to copy the toolbar inside of it. So I'm going to copy the toolbar, hit delete, and then paste it back inside of the app bar layout. And now, because the toolbar is not the top level element anymore, I'm going to take the constraints from the toolbar, move them outside to the app bar layout. So now the app bar layout is constrained to the top, the start, and the end of the parent, and the toolbar is just wrapped by the app bar layout. And now the one last change to make is go down to the nav host fragment, and it likely has a constraint of constraint top to the bottom of toolbar. We're just going to update that to be bottom of app bar layout. So to kind of double check your work, if you come back to the design view here, you should see the same rough layout here. You have an app bar layout at the top and the nav host there in the middle. So if we run this one more time, we can just double check our work here. And there we go. So it's very subtle, but you can now see that our app bar has elevation to it. And as you scroll content, it's much more noticeable. You can see that the content really looks like it's going underneath the app bar, which sits at a higher level or higher elevation, which is what is expected in material design. So that has been it for this week. We've gone through a lot here. We've loaded data. We've now saving our location. We've learned how to load images. In the homework assignment, you'll be asked to sort of build on what we've done here, and then also add a couple of these things in some additional places for some extra practice on how to load images or how to grab extra information out of the API response. It's all going to be things that we've already walked through here. You'll be applying them simply in an additional location. So check Canvas as always for the details on the assignment, and reach out to me if you have any questions, and I will see you all in our next lecture. Hey devs, and welcome back to week 8 of our ongoing Android development course. This week, we're going to be refactoring forecast details fragment to take advantage of some of the new features coming out of Android Jetpack. We're going to make use of a view binding to remove all of the calls to find view by ID within that fragment. We're going to make use of the Android architecture component view model to format and manage our UI data and to persist that data across configuration changes. So by the end of this week's assignment, you should have a basic implementation of MVVM within your forecast details screen. This will demonstrate to you how separating your code into these separate layers can make it smaller, easier to work with, and more extensible as you were to build this out into a more fully functional app. All right, let's jump into our lecture for this week, We're going to be talking about view binding, the Android architecture component view model class, and a general MVVM architectural pattern. So we'll go over a quick project overview. What are we building this week? Then we'll talk a bit about view binding and how we can use it to replace calls to find view by ID. We'll then introduce the Android architecture component view model and talk a bit about MVVM and how we can use the view model in that architecture. And then finally, we'll wrap it up with a brief overview of view model scoping and how we can use view model scoping to save data across configuration changes. So for our project demo, now for the last 8 weeks or so, this would be the point where I would jump over to the emulator and walk through the new functionality we're adding. However, this week, the app looks pretty much exactly the same. We're not updating anything to the UI this week. All the changes are going to be kind of internal, more of how we're structuring our code. So this week, we're going to be focusing exclusively on refactoring forecast details fragment in a few different ways. We're going to use view binding to replace all of our calls to find view by ID. We're going to introduce the Android view model class and use that to implement a simple MVVM architecture within forecast details fragment. And then finally, we're going to save data across configuration changes by using view model scoping and reusing existing view model data when the fragment and the device is doing things like rotating around. So let's jump into view binding. What exactly is view binding? So view binding is really a new feature, new functionality within Android, really sort of becoming popular in the past year. And effectively what view binding does is it's a compiler option that will generate statically typed view references for us. And this essentially removes any need to call find view by ID. Within an activity, or in this case, a fragment, we can get a reference to a binding class for a particular layout. So for our forecast details fragment, for example, we have a layout called fragment forecast details.xml. Once we've enabled view binding, that XML gets converted into a binding class that has a very similar name. So instead of fragment forecast details.xml, we get a binding class called fragment forecast details binding. We can then inflate that binding very similarly to how we would inflate a fragment layout anyways. We call inflate, we pass in the layout inflator, the parent container, and false generally because we don't want to add it to the parent automatically. Once we have the binding class, this is where the real magic happens. Any view within the layout XML that has an ID property will have a property added to the generated binding class. We can then reference those views using the binding class. So in this case, we call binding.descriptionText to get access to the text view in our fragment layout with the ID of description text. And similarly for date text or for the forecast icon. And so because we have this generated binding class, we don't need to look up the views using find view by ID. And where this is really nice is that it gives us compile time safety. If for some reason we remove a view but don't update our code, we're going to know about it because it won't compile anymore. Whereas before, if we're using find view by ID, that check is done at runtime, and it might cause us to crash when we try to inflate that view at runtime. So now, like I mentioned, this is all happening with a compiler option, essentially, that's generating this code for us. And we enable that in our apps build.gradle file. So within the Android configuration block, we add this view binding configuration and set enabled equals to true. Once you've done that and done a sync and maybe a rebuild on your project, when you have layouts, it should generate these binding classes for you based on the XML. Now, our next topic for the week is view model, specifically the view model class from the Android architecture components. And this week, we're going to be looking at how we can use the view model to help us separate business logic from the UI presentation logic within our app. Now, the kind of official definition of view model, I think, is actually pretty good here. So we're just going to take a look at that. The view model class is designed to store and manage UI-related data in a lifecycle conscious way. The view model class allows data to survive configuration changes, such as screen rotations. We're going to look at that example. So basically what this is saying is the view model is a good place to basically decide what needs to be on the screen, expose that data to your fragment or your activity, and then because the view model is responsible for handing out that data can then survive configuration changes such as rotating your screen, meaning that you don't have to reload data anytime the screen is rotated or any other number of configuration changes happen. So this is a really nice win for us because it helps our apps be more efficient, require less network usage, etc. So with the view model, we can do a number of things. We can use it to manage our data sources. It might have multiple repositories and it pulls data in from all of them, combines them all together, and then it might format that data. So it might take in a date timestamp and turn that into a displayable date. It might build up an icon URL based on some type of code or convention in the API. The view model then helps us save data across configuration changes. We can then expose that data to be displayed in the UI using something like live data, so that the UI will only be updated when it's active, but the view model can update itself independent of needing to know about the fragment and what state it's in. Now, the view model lends itself pretty well to implementing the MVVM architectural pattern. Now, if you aren't familiar, MVVM stands for Model View View Model, and its goal is to help us separate business logic and UI presentation logic. Currently, we have really all of our logic within the fragment. So it means we're loading some of our data or getting access to the data in the fragment. We're then formatting it there and binding it into the UI. And in small screens and small projects like ours, that's usually not too much of an issue. But for larger code bases, production code bases, that quickly becomes unmanageable. And if you want to scale your app properly and have it be maintainable, have it be easy to work with, it's good to separate that logic out because it gives you clearly defined boundaries as to what types of code to put where. It makes it easier to debug issues. It makes it easier to add code. It's just a good practice all the way around. So in MVVM, you have these three components. You have a view model, and a model. And these are all kind of abstract. It's hard to know exactly what's going on here. So in our case, a little bit more concretely, the view layer in our case is going to be the fragment. We're going to work to make the fragment do as little as possible so that the majority of all the logic and the thinking behind what's going to go onto the screen is done elsewhere. Now, the view model is the place where that's really going to happen. We're going to take in the arguments, the data that we need, format it in the view model, and then expose it to the fragment using live data. And then in more complex examples, the model layer, that could be everything in like your repositories. That could be your databases, your network services. All the stuff that is actually fetching the data could be considered in the repositories. And so data usually wants to flow between these layers in very distinct ways. Your view model is likely going to be getting data from the repository, and then it's going to expose data to the fragment. And now the fragment might need to send events back to the view model like, hey, I clicked a button. And then the view model might need to respond to that by going out to a repository or a service and saying, get me some new data, or make this network request. So the idea here is to give you clearly defined patterns and clearly defined layers with which to structure your code. Now, once you've put all of this new code into your view model, we want to make use of view model scoping to make sure that we're reusing data. And the reason we want to do this is that we want to avoid creating new view models and thereby loading additional data in response to things like configuration changes. Now, we haven't talked too much about configuration changes in this course, but a configuration change is something like a device rotation, for example, where you're going from portrait mode to landscape mode, or maybe vice versa. Because this might require a new layout to be loaded, we get a configuration change. And by default, a configuration change usually means that the entire activity is destroyed and recreated, and thereby fragments destroyed and recreated. So if you don't take advantage of view model scoping, what'll happen is you'll create a new fragment, then a new view model for that fragment, and you'll load the data all over again. If you have expensive data, meaning it takes a lot of network bandwidth, it takes a lot of database time to load, this then becomes really expensive and is hard to manage and leads to poor user experiences. So we want to reuse our existing view models, and we can reuse those within a couple different scopes. And when I say scope, essentially that defines how long the view model will stay active. So for example, you could define a view model scope that says, for as long as this fragment is on the screen, this view model will be active. Or you could say, for as long as this activity is alive, we're going to reuse the same view model. So anytime someone asks for a particular type of view model, we'll hand back the same one. And similarly, you could do the same for a navigation graph. Now, like I said, what this does for us is it helps our apps be more responsive. We make fewer network requests, database requests, and an overall better user experience. And we're going to see step by step how to combine all of these things to really make our code here easier to manage and more performant. You're going to see that the fragment becomes much less code. The view model becomes very clear how it's taking in data and then formatting that and exposing it to the UI. And we'll take advantage of view model scoping so that we're not reloading and reformatting data when the device is rotated. And so with that, we'll go ahead and jump over to Android Studio and dive into our code updates for the week. Okay, so we're going to start off this week by taking advantage of the view binding functionality that has been newly added to Android. So to do this, we're going to open up our apps build.gradle file. Now within this, we need to configure a build option for our Android app. So within this build.gradle file, we'll find the Android block here. Then we'll scroll down to the bottom, and below where we have configured our Kotlin compiler options, we're going to hit return, and we're going to type view binding followed by an open and closed curly brace. And then we're going to type enabled equals true. So this should go ahead and enable the view binding compiler option within our project. And this is going to generate binding classes for us from our layout files. So after we've updated this, we're going to be prompted to sync our Gradle file once again. So we'll go ahead and hit sync. Then we're going to want to open up forecast details fragment. And now this week, we're going to be working on refactoring forecast details fragment to take advantage of view binding. And after that, we're going to refactor this to make use of an MVVM UI architecture pattern. So now that we are in the forecast details fragment, we want to make use of the binding class that the view binding compiler option generates for us. So to do this, we're going to start off by creating a couple of new properties to manage our binding class. And this is going to follow the pattern very similar to that that we've used for managing live data in some of our repositories. We're going to have a private internal binding option, and then we will have more of the public facing one that we want to be a part of our main API for this class. So to start, we'll type private var underscore binding colon. Now for the type, we want to access the binding class that was generated for the fragments layout file. So to do that, we'll type fragment forecast details binding. And then this is going to be a nullable type. So we'll add the question mark, and then we'll initialize that to a null value. Now we're going to create the non-null property that we are going to take advantage of when we want to use the binding in the fragment. And so to start, we're just going to leave a little comment here that says this property only valid between on create view and on destroy view. And we'll talk a little bit more about why we want to add this comment and what it means in a moment. So after we've added the comment, now we can type private val binding. And now we're going to add a custom getter for this property by typing get open and closed paren, then an equal sign underscore binding. And now we're going to add a double exclamation point here. And the reason for adding the double exclamation point is because it will enforce the type of the binding property to be non-null. So to illustrate this, we'll come back to our binding here, and we're going to once again make use of the fragment forecast details binding type. Once we've added that type, we'll see that we have this error on the underscore binding assignment. This error is basically telling us we have a mismatch. It's saying that we have requested a non-null binding property, but we've passed in a nullable binding property because underscore binding is a null type. Now, as we've pointed out in the comment, we want the binding property to be valid only within certain lifecycle methods of our fragment, because that's when we expect the view to actually be available and be valid. So that's why we have these two properties. We have the underscore binding that represents the fact that this might be null throughout the entire lifecycle of the fragment. And then we have the non-null binding property to represent the non-null expectation of that property within the onCreate view and onDestroy view lifecycle. So to enforce binding being non-null, we're going to assign underscore binding and we add double exclamation point because that will throw an error if for some reason underscore binding is null at that point. So we're just going to go ahead and remove the explicit type there because it can be inferred automatically. Now that we have our binding class or our binding property set up, we want to actually make use of that binding. Now, ultimately, using this binding class is going to let us replace all of our calls to find view by ID within the onCreate view method of our fragment. To start, we're going to make use of the binding class to replace the call to the layout inflator. So we'll come into onCreate view and we're going to delete the first line here. And instead, we're going to update it to assign underscore binding equals fragment details binding dot inflate. Within the inflate call, we're then going to pass in the layout inflator, the container, and we'll pass in false. So this actually looks very similar to the way we were inflating the layout before. So now this has given us access to the binding object. we need to come down to the bottom of onCreateView, and instead of returning layout, now we're going to return binding.root. Binding.root is a property available on all the generated view binding classes. And root essentially just gives you the root view. It returns you back the whole layout. So now that we have initialized our binding property within onCreateView, we need to clean it up in onDestroyView. So I'm going to hit return a couple times, and we're going to add an implementation of onDestroyView. To do that, I can simply start typing on destroy, and it should give you several methods to choose from. So if you select down to onDestroyView and hit enter, it should generate that implementation for you. So now hit enter, and below the call to super.onDestroyView, we're going to type _binding equals null. So this will just work to ensure that we are clearing the reference to the binding, because we want the views to be cleaned up in memory when they are destroyed. This will help us prevent memory leaks and help us keep our app performant. So now for the fun call in our, now for the fun part of using view binding. We're going to replace all of the calls to find view by ID. So I'll simply come up here and then onCreateView. I'm going to highlight all of those calls to find view by ID and simply delete them. Now we're going to have a number of errors here because we're trying to assign data to view elements that no longer exist. So you can see here, I have a unresolved reference to temp text. So the way to fix this is to use our binding property. And remember, we're going to use the non-null version because within onCreateView, until it's destroyed, we can expect binding to be non-null. So I'm going to type binding dot, and as soon as I do that, the reference resolves. So how is this actually working? Well, if we open up our layout, fragment forecast details, if we look at the XML, you'll see here that for each view, we have added an ID. So if we look specifically at temp text, you'll see that we have an ID of temp text. If we come back over to our fragment, we'll see that matches exactly the property on the binding class. So for every XML layout element in your layout, the binding class will generate a property as long as that view element has an ID on it. So if we come back to our fragment, we can finish updating these references. So I will type binding dot description text, binding dot date text, binding dot forecast icon. And so now we no longer have any calls to find view by ID. And if we deploy our app, it should look just the same as it did before. So I will quickly enter a zip code, click submit, and then I will load up some forecast details, and there we go. It looks exactly the same as it did before, but we have now successfully integrated the view binding library. Now that we've integrated view binding, let's work on implementing an MVVM architectural pattern into our app. To do this, we're going to make use of the Android architecture component's view model class. The view model will serve as our place for loading data and defining the view state that should be bound to our UI. This will help us persist data state across configuration changes such as rotating the device. To do this, we're going to start by opening up our app level build.gradle file over on the left-hand side of the screen. We're going to scroll down to the bottom, and in the dependencies section, we're going to enter in right below the navigation dependencies, and we're going to add the dependency for the ViewModel class. To do this, we'll start by typing implementation, then we'll add double quotes, and we'll type Android X dot lifecycle colon lifecycle dash viewModel dash KTX colon 2.2.0. Now, as always, after we've added our dependency, let's go ahead and do a resync to make sure we have entered the dependency correctly. And if the sync completes, we should now be able to make use of the ViewModel class. So to do that, let's start by opening up our forecast details fragment once again. So we're going to make use of a new ViewModel for forecast details fragment. We're going to use the ViewModel to format our data, and it is going to then expose data using live data, and then within the fragment, we will observe the live data and update our UI. So to start all of this off, we're going to come to the project pane on the left-hand side of the screen. We're going to right-click on the details package, go to New, Kotlin File or Class. Then we're going to select Class, and for a name, we're going to call this Forecast Details View Model, and then hit Enter. Now this should generate a class for you, and then we're going to extend ViewModel by typing colon ViewModel. Now this should start off as an unresolved type, and it should prompt you to import that type. To do that, we can type Alt-Enter, and it should add the proper import for you. And just to double check, make sure that you have import androidx.lifecycle.viewModel at the top of your file. Now ViewModel has a constructor, so we need to go ahead and add open and closed parentheses. And now we have a fully functional, although very empty ViewModel. Now we can go over to our forecast details fragment, and underneath our args property, we can go ahead and start using the ViewModel by typing private val ViewModel equals forecast details ViewModel. So for now, this is just really a placeholder to signify that we will eventually be getting a reference to this ViewModel and using it in the fragment. However, for now, we're going to go back over to forecast details ViewModel and start working on implementing the live data that we want to expose that will represent what we want to show on the screen. So we're going to create another class here by once again going to the project pane on the left-hand side of the screen, selecting details, right-clicking, going to New, Kotlin File or Class. We'll select Class, and this time we're going to name the class Forecast Details View State and hit Enter. We're going to make this a data class by adding the data modifier at the end. And now we're going to add open and close parentheses, and then we're going to define the fields that we want to store in this forecast details view state. This will represent the data that we're ultimately going to display on the screen. So what data do we want to put in here? Well, if we open up our fragment, what data are we setting into the screen? We have a temperature value, we have a description, we have a formatted date, and we have an icon URL that's being loaded. So those are the values that we're going to add to our view state. So we'll start by defining val temp of type float. Then we'll add val description of type string, val date of type string, and val icon URL also of type string. Now let's go back to forecast details view model, and we're going to make use of this new view state type. And we're going to follow the same pattern we've used in our repositories for working with live data. So we'll come within the class body, and I'm going to start off by typing private val underscore view state colon mutable live data. Once you've typed mutable live data, it'll prompt you to add the import. You can hit Alt Enter to automatically add that. Once again, at the top of your file, make sure it's imported the proper thing. You should see androidx.lifecycle.mutable-live-data. Now, after the mutable live data, we have this open and closed angle bracket. This is asking us for the type that this live data will expose. So this is where we're going to make use of that new view state type. Forecast details view state. So this is signifying that our live data is going to send out new instances of forecast details view state for the fragment to observe. And then finally, we will initialize this by saying equals mutable live data with an open and closed parentheses. And so now, as we've done in our repositories before, we're going to create a public property that mirrors the private one. We'll type val view state colon live data. And again, we'll have to import the live data type here. So I'll hit Alt Enter, and it should add the import for androidx.lifecycle.liveData. We're also going to expose a forecast details view state. And this time we will say equals underscore view state. So this will let us configure our state, expose it via live data, and let the fragment bind it into the UI. This keeps a nice separation of concerns between the business logic of formatting and combining data and the UI logic of placing those individual values into the views. So now that we have this basic live data setup, let's go to the fragment and work on observing this data. So to do that, we're going to come down here, and right below on create view, we're going to add another fragment lifecycle method here. We're going to observe the live data using a lifecycle method called onViewCreated. So I typed onViewCreated, hit enter, and it pre-populated this implementation. OnViewCreated, as the name suggests, is going to be called right after onCreateView. So at this point, our view will be set up. Eventually, our view model will be all set up. And this will be a nice, safe place for us to observe changes in the UI and then ultimately update that UI. So now we'll come below super.onViewCreated, and we're going to start off by creating a live data observer to observe changes in forecast details view state. To do that, we'll start off by typing val view state observer equals, and now we're going to start typing observer, and we want to make sure we're careful here because there are a number of different observer types available. We want to make sure that we select the observer coming from androidx.lifecycle. So for me, I've scrolled down to what is the fourth one for me, and I've hit enter. Now this type is going to expect a templated type to indicate we want to listen to forecast details view state. So within the angle brackets, I'll type forecast details view state, and then I'll add open and closed curly braces. Within the curly braces, I want to rename the it parameter so that it's easier to understand that we're working with a view state. So after the open curly brace, I'll type view state followed by a dash and then a closed angle bracket for our lambda arrow there. Now within this, eventually we're going to update the UI. And for now, I'm just going to leave that comment there because we're not quite ready to do this yet. Now, after we've defined our observer, we want to actually observe the values. To do that, we'll type viewModel dot viewState dot observe. Now we need to pass in a lifecycle owner. So we'll do that by typing view lifecycle owner, comma, and now we can pass in our view state observer. So now when onViewCreated is called, we will create this new observer and we'll start observing changes to the view state. So now the next thing we need to do in the migration to MVVM is to move the business logic of formatting our date from the fragment into the view model. To do this, we need a way to get the fragment arguments into our view model. Currently, we're calling things like args.temp, args.description, using the args property on our fragment. If the view model is going to handle the same types of formatting, we need to get that data then to the view model. Now, there are a number of ways to do this, some that might be considered cleaner code. However, some of those ways are also a bit more complex. So we're going to start pretty simple. We're going to add a method on our view model called processArgs. So I'll open up our view model class here. And I'm going to create this new method by typing fun processArgs. Now, as a parameter to processArgs, I'm going to create a parameter called args:, and I'm going to make it be of type forecast details fragment args. So those args that we get from the fragment, we're going to then just pass that into this processArgs method. So now within this method, we will convert the passed arguments into a formatted view state. To start, we're going to assign the view state we're going to assign a new empty view state. So we're going to say underscore view state equals forecast details view state with an open and closed parenthesis. So now we're going to need to define each of the properties on that data class. So to start, we're going to use a named parameter syntax here, so it's very clear what we're doing. So we were going to assign temp equals args.temp. Then we're going to add a comma. Then we're going to say description equals args.description. Now the next thing we want to do is the date. However, if you remember in forecast details fragment, we're actually doing some formatting of the date. We're using this date format class, and then we're passing in some extra logic here for converting the date from milliseconds into the proper time. So we need to move all of that logic into the view model. To start, we're going to copy the date format top level property from forecast details fragment. We're then going to delete it from the fragment and add it back within the forecast details view model file. So now we have that format available. Let's come back to our fragment, and we're going to copy the line here again that is formatting the date. So I'll do a copy, and then I'm just going to add that and paste it within our new method here. And that's all we need to do for formatting the date. It's the same logic, it just now lives within the view model. And now for our last property on the view state, we need to create the icon URL. Now, just like the date, we're doing some processing for the icon URL. we have this string here that we're passing into the call to forecastIcon.load. So again, we're going to copy this, go back to our forecast details view model, and then paste that in to the assignment here. Now we see that we have this error here. What is the problem? Well, remember, we need to assign the value of the live data as opposed to the whole live data itself. So we'll come back to underscore view state and add dot value. So now this is saying, okay, we are creating a new instance of forecast details view state, and we want to assign it as the new value for our live data. When we do that assignment, it will then update the observer in the fragment, and that observer can then use that to update the UI. So let's go ahead and make that update now. We'll go back to forecast details fragment, and we're going to work on moving the logic out of onCreateView and into our observer in onViewCreated. So let's come down here to the observer underneath our comment to update the UI, and we're going to start by adding our temperature text. So just like before, we can type binding.tempText.text equals, and now we're going to use the view state. So we'll get the updated view state by typing view state dot, and now we want to use the temp. However, if we just use view state.temp, we have an error. View state.temp is a float, whereas temp text is expecting a string. So we need to do the same type of formatting that we are doing in onCreateView. So we're going to come up here and again copy this line. This is format temp for display. And we're going to add that down here within our view state observer. However, instead of passing args.temp, we're going to pass view state.temp. Now, for our next UI element to update, we'll type binding.descriptionText.text equals viewState.description. Then we will say binding.dateText equals viewState.date. Then we'll say binding.dateText.text equals viewState.date. And lastly, we will load the forecast icon. So we'll again use binding.forecastIcon.load, and then we will pass in viewState.iconURL. Now, once we've done this, we can come back up to onCreateView and remove these old calls to the binding class. And now we'll just go ahead and clean up some of the spacing just to reduce the amount of code we have here. And so now let's talk through the flow here again. When our fragment is created, we're creating a new instance of a forecast details view model. In onCreateView, we're getting a reference to our binding class. In onViewCreated, we're adding an observer that will listen to changes in view state coming from the view model and then update the UI based on that new view state. If we go ahead and rerun this, we can now see how this is looking. So if we come over to our week tab, open up forecast details, you'll see that we have an issue here. We only see the icon, and really the icon is only displaying the placeholder. So what is the problem here? Well, if we look at our code, we've set everything up to respond to changes in view state. However, we haven't actually updated our fragment to make use of the process args method that we previously created. So what we can do is in onViewCreated, after the call to observe, we're going to add viewModel.processArgs, and we will pass in the args property of our fragment. So now we should get that initial processing, which will give us an initial state, and we should now see the data in our UI. So if we rerun this one more time, now when we go back to our emulator and view details, we see the forecast details that we would expect. Okay, so now we've returned back to forecast details fragment here. And now we need to take a step back and think about where we're at currently. We've moved a lot of the business logic into our view model. The view model then is responsible for formatting some of that data and then exposing that back out as a view state. And then that gets used to update the UI. So this is nice. We have a much cleaner separation of concerns. The fragment is responsible for binding data. The view model is pulling in data and formatting it properly. So this is a nice win. However, we currently have a subtle issue here. If we look at our emulator, if we were to rotate the device, what would end up happening is that we would actually be creating a new view model each and every time we rotate the device. This is very not ideal because it means that we are instantiating new objects when we don't need to. Now, in a simple screen, this is not really much of an issue. However, imagine we're in a more complex screen in which you're making network requests, loading from a database, or other more intensive actions. We wouldn't want to throw away any loaded data if we didn't have to. Ideally, we could reuse the data that we have already loaded or that we are in the process of loading, and then rebind that data to the new fragment's view when it's recreated on rotation. Now, to actually implement this, we can take advantage of something known as view model scoping to avoid recreating our view model within a specific scope. So a view model scope basically is this concept of, for as long as the fragment is alive, we're going to use the same view model. Or for as long as the current activity is alive, we are going to use the same view model. So what this lets us do is persist our data across configuration changes like a device rotation, and then reuse the data that has already been loaded. And thankfully, taking advantage of this scoping is actually quite easy, and we're going to see how to do that right now. So if we look at the top of forecast details fragment, remember here we previously instantiated our view model by just adding a new property and instantiating it as a new instance of that view model class. To update this, to take advantage of view model scoping, we can make use of a property delegate available within the Android KTX lifecycle functionality for view models. So we'll delete the explicit initialization, and we're going to add a colon forecast details view model to specify the type, and then we're going to type by view model. And now we're going to be asked to import the view models delegate here. So again, I'll hit Alt Enter. And now you want to make sure that you have the proper import once again. So scroll up to the top and make sure that you see androidx.fragment.app.viewModels. Now what's actually happening here? Well, the by keyword here lets us know that we're going to be using a delegate. Basically, a delegate is a software architecture pattern where we're saying we're going to defer some piece of functionality, some lookup. We're going to defer something to this other class. So in this case, view models is a delegate. And if we click into this, there's actually some pretty scary looking code that we're not going to go too far into. But basically, at a high level, this view models delegate can manage a producer and a factory for us. What those two things are going to do is essentially hand us back a view model that is automatically saved and cached for us when things like screen rotation happen. So all of that to basically say that by adding this by view models delegate, we're now not going to create a new instance of our view model every time the screen is rotated. So by adding this, we're no longer creating a completely new view model every time we create the fragment and every time it is rotated or other configuration changes that might cause the fragment to be recreated. So this is a nice win. However, we're still duplicating a little bit of work. If we look at our view model class and we look at our process args function, this is still being called every time onViewCreated is called. And every time we call process args, we're creating a new instance of the view state, even if our live data already has a valid view state. This is wasteful because we can expect the args to be the same if there's already a live data. So we can't have a live data without already processing the args. And if we don't expect the args to change, there's really no reason to recreate that view state for the live data. So ultimately, this means that if our live data already has a value, we can skip updating the live data. So if we come into process args here, we can add a simple check here that says if view state dot value does not equal null, return. And then I'll hit and enter just to space it out. So now in forecast details fragment, if the screen has been rotated, which caused our fragment to go back through its life cycle, we're once again going to call process args. However, because our view model was retained across the configurations change, because we're using that by view models delegate, our view model's view state is already going to have a value. So there's no need for us to create a new one, and we'll just skip and the view data will automatically be bound to the screen. So to test this out, let's go ahead and rerun our app one more time. Our details. And we start rotating our device. We see that we are getting data each time on rotation without any issues. Now let's go back to Android Studio. Now there's one thing I want to point out here, which is that this is pretty specific to our example, the fact that we can get away with this check and process args. Ideally, the args would actually be passed to the view model constructor, and we wouldn't even need this type of process args method. And the reason we want to avoid a method like this is because it introduces this potential for duplication of work. It also means that process args could be called multiple times for multiple locations. And really all we want is to say, create a view model, and here's everything you need to make it work up front. And then we don't have to worry about that data changing. It's really getting towards the idea of immutability. We don't want things to change unexpectedly for us. So there's one more change we can make to how we are initializing our view model to help with this process. And to do that, we're going to make use of a view model factory. So we're going to go to the top of our forecast details view model class here. We're going to hit enter a couple times, give us some space to work. And we're going to create a new class called forecast details view model factory. So we'll add class forecast details view model factory. Now within the constructor, we're going to add a property called private val args colon forecast details fragment args. So remember, we want to be passing these args into the view model. So we're going to pass them first into the factory, and then the factory will use them to create the view model. Now this forecast details view model factory will extend view model provider dot factory. Now we'll need to make sure we import the view model provider class. That should add an import for androidx.lifecycle.viewModelProvider at the top of your file. And then I will add some open and close curly braces. And now to finish out the implementation of this, we need to implement a method called create. Now create is kind of a scary looking method here. So I don't want you to worry too much about the details here. Basically what this is saying is we want to create some type of generic type with this method. And so it's up to us to make sure that the type that's being created is specifically our forecast details view model. So within this create method, we're going to do just that. We're going to make sure we can create the proper type and then return that view model if we can. So we'll say if model class dot is assignable from forecast details view model class.java return forecast details view model, and then we will pass in the args. Now we see an error here because we don't currently have a constructor for our view model that takes in the args. So let's just quickly add that to the view model. We'll come down to forecast details view model. We'll add a primary constructor by adding the open and close parentheses. And we'll type args colon forecast details fragment args. Now we will update the view model to use those args in just a moment, but for now we'll come back up to our factory and we need to finish this return statement. The return statement is expecting a generic type here. So we have to do this little trick and add as t after the instantiation of our view model. All this is really doing is making this return as a generic type so that this generic factory method is happy. Like I said, don't worry too much about this. This is some more advanced stuff. But the important part here is that we are calling is assignable from forecast details view model. So that makes sure that we can create the view model. And once we've checked that we can create it, we create a new instance of it and we return it. Now, after the if statement, we're going to add a call that basically will throw an exception if the previous statement fails. So we'll add throw illegal argument exception, and for the message, we'll put unknown view model class. So if for some reason our factory fails to create the view model we expect, we'll get this exception giving us a pretty helpful message that should help us figure out what's going on. So now let's make use of this factory. We'll go back to forecast details fragment. Now let's find our view model property here. And then we're going to go to the line above, hit enter a couple times and give us some space to work. So we're going to start off by creating a private late init var called view model factory of type forecast details view model factory. Down in on create view after we've initialized our binding class, we're going to assign view model factory by creating a new instance of it. So view model factory equals forecast details view model factory, and we'll pass in the args. Now we'll scroll back up to the top and we can update the initialization of our view model. So we'll come towards the top to our by view models delegate call here. Within the parentheses for by view models, we're going to hit enter, and we're going to use named parameter syntax to specify a factory producer. For that factory producer, we're going to pass in a lambda, which we can do by adding an open and closed curly brace. And within the lambda, we're going to simply pass in our view model factory. So what this has now done is it's now said that when the by view models delegate does its magic behind the scenes to create a new instance of our view model, it's going to use our view model factory to do so. So it's still going to give us the nice caching that we hope so across configuration change, but it's now going to be able to pass in the arguments to the constructor of the view model. So now we can come back to forecast details view model, and we can actually remove the logic here for initializing the view state value. We can remove that from process args. And now we're going to create a new init block. Now remember, a init block's essentially like a constructor. So when this view model is run, this init block will be run. And when that init block is run, we are going to use the args that were passed into the view model to create a forecast details view state and set it into our live data. And so now process args is essentially empty, and we can just go ahead and remove that. And if we go back to our fragment, we can remove the one usage of process args. And now, if we redeploy the app one more time, and as we rotate the device, we still have those nice forecast details. Implemented a basic MVVM UI architecture into your app using live data and view binding. And you've taken advantage of view model scoping to make sure your data is not being reloaded across device configuration changes like screen rotation. This is a big win towards adhering to Android best practices and for just making your apps efficient and responsive for your users. Hey devs, and welcome back to week 9 of our Android development course for beginners. This week, we're going to be working on building adaptive UI. That is, we're going to be working on building UI that adapts to different types of screen sizes and different logical UI states within our application. Specifically, we're going to be looking at adding a loading indicator when we are fetching our forecast data from the network. We're going to add an empty state so that when users install our app for the first time, they aren't presented with a simple blank screen. And then finally, we'll show you how to adapt your UI to larger screen devices like tablets so that you can take advantage of more screen real estate and make a better experience for your users across all form factors. Okay, let's jump into our week 9 lecture on adaptive UI. So as usual, we will look for our project demo, give you a sense of what we will be building this week, what updates we'll be making to our weather app. And then we will talk about sort of 2 different components to adaptive UI. We'll talk about building UI for different logical states within your app, and talk about building UI for different device form factors. So what are we building this week? Well, we'll be adding an empty state to our current forecast fragment and weekly forecast fragment. We'll be adding a loading state to both of those fragments as well. And then we will be adding a tablet specific layout for our current forecast fragment to take better advantage of the increased screen size on a tablet. So here we have a look at both a Pixel C emulator and a Pixel 3 XL emulator. So we can see on the Pixel C emulator here that we have a much larger text and it's centered in the screen on the tablet, as opposed to on the phone, we have smaller text and it's in the upper left-hand side of the screen. So this is something we're going to walk through, and we'll leverage custom resource qualifiers to provide different layouts for the large screen device and the smaller screen device. If we switch over to our weekly tab, we'll see briefly there that we had this empty message and a loading message indicating that there was some background work going. So that's the other piece to this. We're going to be adding those empty states and those loading states to both our current forecast fragment and our weekly forecast fragment as well. This improves the first-time user experience and just makes our screen more responsive as users are walking through the app. So let's introduce the idea of adaptive UI. The concept of adaptive UI probably means different things to different people. For me, I think of it kind of in two ways, two concepts. The first is building UI for different logical states within your app. Now, what do I mean when I say different logical states? So I mean things like this. Are you handling an empty state? What happens when your app doesn't have the data it needs? Do you have a loading state? What happens when data is being loaded? Is there any type of indicator to the user about what's happening? Now, what do you show on the successful state? What do you want to be showing on the screen? And what happens if there's an error? How is that error surfaced to your users? Do they see it? Do they get some type of hint as to how to recover from that error? These are the types of logical states that I think that we really should account for as app developers. The more of these states we can account for, the more responsive our app will be, the fewer sort of unaccounted for states the user can end up in, which means they will have a better user experience. And it means that they might be able to recover from errors more easily, which usually keeps users happier with your application, more engaged, and makes the app more useful for them. So it's very important that we handle this. So this is why we're going to be looking at adding in an empty state so that when the user installs our app for the first time, we don't just have these blank fragments and no hint as to what the user should do. And that's why we're going to add a loading state so that when we make the calls to load the current forecast and load the weekly forecast, that there's some type of indicator that something is happening in the background. And now the other part of adaptive UI that I consider is building UI for different form factors. And on Android, this is really important. How does your app look on a small phone or on a large tablet? Could you customize your UI to take better advantage of specific form factors? You might design a specific screen differently if you're thinking about a 3-inch phone versus a 10-inch tablet. And these are important questions to ask yourself as you're designing your app. Different form factors that we can account for are screen sizes. Like I said, are you using a small phone, a medium-sized phone, a large phone? Are you using a tablet? We can account for screen orientation. Are you in portrait mode? Is your user in landscape mode? Are they switching back and forth between the two regularly? Are you on a device that might have multiple windows, and do you support multiple windows? Is the user using a foldable device? So maybe they have one screen when it's folded, and when they open it up, there's maybe one larger screen or two separate screens. And the screen could be resizable. On Chromebooks in particular, users can resize the screen or resize your Android app, your activity, so that it might be a whole bunch of different sizes all within one single process of your app running. So the more of these different configurations we can account for, the more dynamic our UI can be, and the better experience we'll have across a wider variety of form factors. And now the way that a lot of this works is with resource qualifiers. We can use resource qualifiers to provide alternative resources for specific device configurations. These configurations end up taking the place of, or these configurations take the form of different resource directories with these special qualifiers added to the end. So for example, we have our layout directory within the res directory. This is where we've been putting all of our layouts in this course. However, if we wanted to add a layout specifically for a large screen device, we could add a layout-sw600dp resource. This resource directory would say any layouts in this directory will only be used for devices whose smallest width is at least 600 dp. So this is a good way to provide different resources for tablets. Similarly, you could create a layout-land resource directory, and this would be layouts specifically for landscape orientation. And this applies to different types of resources as well. You could provide different dimensions for a large screen device using dimens-sw600dp. And it's not just things like a smallest screen width or orientation. You could also create different values if you wanted for, let's say, night mode versus a regular standard daytime mode. And there's a lot of different qualifiers there, and all of those can be leveraged to make your apps more adaptive for more Android users. So let's end the lecture here. We'll jump over to the demo and we'll walk through how to start making our simple weather app a little bit more adaptive for our users and for different form factors. Okay, so here we are back in Android Studio. And the first thing that we're going to look at is adding an empty state to our current forecast fragment. Now, to demonstrate why this is useful, the first thing I'm going to want to actually do is go to my emulator, and I'm going to want to uninstall my app because we want to examine what our app looks like during the first time user experience. So once I've uninstalled my app, I'm going to go back to Android Studio. I'm going to then reinstall the app to my emulator. And now back here on the emulator, we can see why an empty state for our screen would be helpful. When we first open the app, before we've loaded any type of weather data, we just see this blank screen here. And we see it on both the Today tab and on the Week tab. Now these blank screens aren't helpful. We don't know if there's no data available. We don't know if there's some type of error. We're not sure where we're supposed to go next. So this is what we're going to fix. Instead of having a blank screen, we're going to add a message there that says something along the lines of, please enter a zip code to see the current forecast. So let's jump back over to Android Studio. And now we're going to open up current forecast fragment. Now within current forecast fragment, we can see in our onCreate view that we currently have 3 views that we're getting a hold of here. We have our kind of root level view, then we have the location name and the temperature text. So location name and temperature text represent the 2 views that we display once we have data. So really what we want to do here to add an empty state is add another view to this layout. We'll get a reference to it in the same way we're referencing location name and temp text. And then during different points of our data loading and display lifecycle within the fragment, we can set that view to visible or gone depending on whether or not we have data. So let's open up into current forecast fragment. And so now we're in fragment current forecast.xml. And if we go over to the design view here, we can see what our fragment looks like when we have data. So now let's add our new empty view text by grabbing a text view from the palette and dragging that over into our constraint layout. Now I want this to be displayed roughly in the center of the screen. So I'm going to start by constraining this to the end of the parent, to the start of the parent, to the top of the parent, and then to the bottom of the parent. So once that has been constrained to the parent, it should sit right in the middle. Now I'm going to go over to my attributes panel on the right hand side of the screen, And I'm gonna actually adjust the vertical bias a little bit by dragging this slider. And you'll see as I adjust this slider, it moves that view up or down. Now I'm gonna adjust it up until it sits at about 33%. So this will make it so that that text view there sits at about the upper third of the screen. That's just a nice way of balancing the screen out. People tend to read from the top down, so having that message a little bit further to the top will catch the user's attention a little bit more quickly and help the screen feel balanced since we already have a button towards the bottom of the screen. So now the next thing I want to do here is adjust the default visibility of this text view. Now by default, we want this view to be visible until we have data. So what I want to do is actually, again, come to the attributes pane here. And by default, I'm going to go ahead and explicitly set this to visible. And then for the tools visibility, I'm going to go ahead and just leave that blank for now, since by default, this is going to be visible. Now, by default, we don't want the location name or the temperature text to be visible. We want to only make those visible if and when we load data. So I'm going to click on my location name text view here, the one that says Seattle, and then also come over here to the attributes pane. And now for this one, visibility, instead of it defaulting to visible, I'm going to mark this as gone, but I'm going to set the tool visibility to visible. So this will make it so I can still see it here in our design view, but it won't be visible in the layout until we actually explicitly mark it to visible at runtime. And now I'm going to do the same thing for the temperature text. So I'll make it default to gone, but I will set the tool visibility to visible so we can see it here on this screen. So if we were to then just quickly run the app, let's take a peek at what this is looking like right now. So I will deploy that to my app. And then I will switch over to the emulator. And so now we see that by default, we're still not seeing the temperature text and the date. That's perfect. And then we are seeing now by default our empty message. Now, right now it just says text view. We're going to update that in a second, but this is a good start. So we're now actually seeing something on this screen when we load it. So let's go back over to Android Studio now. And we're going to update this text message. So down here in the common attributes pane where it says text, I'm going to update this to say something along the lines of enter zip code to see current weather. Perfect. So now we've got this nice message here. Now there's a couple things that we might want to do here just to make sure this looks good across all devices. And to demonstrate this, let's first see what it looks like on our primary device. So again, I will run this on my emulator. And we'll see here on this emulator, it looks perfectly fine. It's nice and centered, and it looks pretty okay. Now, if I were to come back over to Android Studio, and let's say we want to update this text appearance to be something larger. Let's say we want this to look something more like a display 2 or a display 3 or something maybe a little bit more reasonable. Let's say display 1, which is still quite a bit bigger. We'll start to see kind of an issue here. By default, this text is left justified, and it's also not centered in the screen at all. So what this means is that on smaller devices, this text is going to be pushed over to the left-hand side of the screen like this, and there's going to be no margin or anything. And this typically isn't what we want when we think of nice looking design. So what we want to do here is start off by adding some margin to the left and right-hand side, or really the start and end of this new text view. So I'm going to select the text view, come to the layout pane on the right-hand side of the screen, And then I'm going to select the drop down here in the layout panel. And I'm going to select the left drop down, and I'm going to select 16, and you'll see that it automatically pushes that over from the left side of the screen by 16 dp. And then if I were to actually do a little bit more, let's say 32, you'll see it pushes it over even more. Now I'm going to leave it at 32, and then I'm going to select the right one and also select 32. And we'll see that all that's done is now push it back over. Now, this is a subtle thing to watch out for when you're looking or when you're working with text views and constraint layout. Constraint layout will only honor margin if you set your width to 0 dp. So you see, as soon as I've changed the width of my text view to be 0 dp, now all of a sudden I'm seeing the 32 dp margin on either side. By setting 0 dp, we're indicating to constraint layout that we want the constraint layout to honor all the constraints. So in this case, we want it to honor being attached to the left and right of the parent, but then also honor the other properties like margin. So that's something to look out for. If you're working with constraint layout and trying to center some text, or you're trying to wonder why things aren't aligning quite right, double check whether or not you're using wrap content, or maybe you should be using 0 dp to let the constraint layout do its thing. So here we now see that this text is kind of nicely centered in the middle a little bit. We have margin on each side. However, the text is still left justified. So to center that text and make it center justified, we can again select our text view, come down here to the all attributes dropdown, and we're going to scroll all the way down towards the bottom, and we're going to be looking for text alignment. If I select the drop down here, I can select center, and we'll see now it aligns that text nicely in the center of the screen. So now if I run this again, and I'll switch over to my emulator, we'll see that we have a nice looking empty state here. So now the next thing that we need to do is actually adjust the visibility of this empty state based on whether or not we have data. So again, back in our design view, let's click on this and let's give this a meaningful ID. So I'm going to select the ID property in the attributes panel, and I'm going to name this I'm going to name this empty text. So now I'll come to current forecast fragment. Now in my onCreate view, right below the line where I get a reference to the temperature text, I'm going to create a variable for the empty text. So I'll type val empty text equals view dot find view by ID. It's going to be of a type text view, and I'm going to pass in r.id dot empty text as my ID. So now, where are we actually updating the visibility and the properties of these text elements? Well, that is in our current weather observer. So right here for me, I see that when I get an updated current weather object, I'm updating the location name text and the temperature text. So what I want to do now is when we get a new weather object, we want to say empty text dot visibility equals view dot gone. So what this is saying is that when we correctly load some data, go ahead and set our empty text to gone because we don't need it anymore because we have data. So now that we've updated that visibility, let's run this app and see how this looks. So here we are. We nicely see our empty screen. So let's go ahead and enter a zip code now to properly load some data. I hit submit, and we see that our empty text is now gone. However, we don't see our weather data. What's the problem here? Well, back in Android Studio, if we go to our layout again, remember that we updated the visibility of the location name and the temperature text to be gone by default. We can see that here in the attributes panel. We can also see it if we were to come into the code. We can see the visibility set here to gone for the location name and gone for the temp text. So what this means is that inside of our current weather observer, at the same time that we tell the empty text to be gone, we need to tell the location name and the temperature text views to be visible. So I can do that by hitting enter and typing location name dot visibility equals view dot visible. And similarly, temp text dot visibility equals view dot visible. So now when I run this, now we see that we have that weather data displaying as expected. And if we switch over, we'll see that we see the empty text for a brief moment, and then we see the loaded temperature data. So this is a very basic example of how we could add this type of empty text to our layout. Now this type of pattern is a good practice, and there's lots of different ways you could go about doing this. This might not necessarily be the most ideal because it leads to kind of a quick flash in the UI. However, there are ways we could get around that in the future if we were doing a more advanced course here. But the main point here is to think about, what do your users see the first time they view your app? Are they presented with an empty screen, or do they see some type of useful message that gives them a hint as to what they should be doing? Now that we've added an empty state, the next thing that we want to add is some type of progress indicator to indicate to the user that some type of background work is being done. This is really useful when performing long-running network operations or database access or any other type of long task where the user is waiting on some type of response. By adding a progress indicator, it gives them some indication of what's happening. If they click a button or they enter some text and nothing changes in the UI, they have no idea of knowing if the app is doing something, if they have messed up somehow. It's a very confusing thing for the user. So a progress indicator is a great way to help give them feedback and help them understand that the app is actually working and working for them. So similarly for the empty state, we're going to start by going into our layout XML file. And I'm going to go to the design view. And over here in the palette where we previously got our text view, we're going to come to the widgets section. And we're going to look for a progress bar. Now you can see there's kind of two styles here. There's a progress bar that's circular, and then there's a progress bar that is more horizontal. Both of these have their places within Android development. Horizontal progress bar can be used for an indeterminate amount of time, or for a determinate amount of time. And actually really either progress bar can be indeterminate or determinate. And all this means is indeterminate means I'm just going to load and load until something is done. Determinate means I roughly know how much work I need to do, and I'm going to give regular updates. And so that might be some type of status bar that goes 1, 2, 3, all the way up to 100% done. Now in our case, we're going to use a circular progress bar, and we're going to use it in just the default indeterminate state. So it's just going to spin until the data is loaded. So I'm going to select that and drag that over into my UI. And I'm going to place this below our empty text here. So I'm going to align the left to the left of the empty text. I'm going to align the right of the progress bar to the right of the empty text. And then I'm going to constrain the top of the progress bar to the top of that empty text. Then I'm going to click on the progress bar, come over to the attribute panel, and the default ID of progress bar, I'm actually okay with that. So I'm just going to leave that as progress bar for now. And now for visibility, I want to make this gone by default because we don't want to start out showing progress. We only want to show progress once we've actually started loading data. However, for tools sake, so that we can see what this layout might look like, I'm going to set the tools visibility to be visible. So if I run this to my emulator, we'll just double check that it's not showing by default. Perfect. We saw the empty text, we see the loaded state, but we didn't see the progress bar. That's exactly what we're looking for at the moment. So we'll go back over to Android Studio. Now I'm going to go into my current forecast fragment, and we need to get a reference to our new progress bar. So I'll type val progress bar equals view dot find view by ID. This time I'll type in progress bar within the angle brackets to specify the type. It's going to prompt me to import, so I'm going to hit Alt Enter, and if I scroll up to the top, that should have imported this android.widget.progressBar import. And then now down here, I'll finish my find view by ID call by passing in r.id.progressBar. So when do we want to show this progress bar? Well, we want to show the progress bar after we've gotten an updated location, and we're going to then make the call to load current forecast. So let's update our location observer here. So on the line that says is location.zipcode, after the arrow, I'm going to copy this line of code that says forecast repository.load forecast. I'm going to delete it temporarily, and then I'm going to add in open and close curly braces, and then paste that load current forecast line back in. So all this is doing is changing this from a one-line expression to a multi-line expression. And we're doing this because we want to do multiple things now in response to getting a new zip code location. And the added line that we want to add is saying progress bar dot visibility equals view dot visible. And now back up in our current weather observer, when we get an updated weather object, we want to say progress bar dot visibility equals view dot gone, because those two things really represent the life cycle of the loading operation. When we call the load current forecast method, that is starting this load operation. And for as long as it takes for that to finish, we're in the loading state. And when we get the new weather, we're now no longer in the loading state. And so we set the progress bar to gone. So now if I run this one more time and I switch back over to my emulator, we'll see that we didn't see the progress bar there. However, if we jump over, it's very, very brief. The data is really, it's loading so fast that we're not seeing the progress bar very much. However, the fact that we saw it at all shows that we're on the right track. So now what we want to do is basically apply these same things for our weekly forecast fragment. And the reason we want to do it for the weekly fragment is because this data takes a little bit longer to load, and it'll give us a better sense of what these new empty and loading states look like in our app. So we'll come back over into Android Studio, and then we're going to open up weekly forecast fragment, and then click to open up fragment weekly forecast.xml. And so just to remind ourselves what this looks like, we have this recycler view, and then we have our location entry button. And now what we really want to do here is add this same empty text view and the same empty progress bar from current forecast fragment and use it here in weekly forecast fragment. So to make this pretty easy on ourselves, we can open up fragment current forecast.xml. And then I'm just going to scroll down, and I'm going to copy the text view and the progress bar that we used in current forecast fragment. I'm going to open up the XML for weekly forecast fragment, which is fragment weeklyforecast.xml. I'm going to switch over to the code view. And then here, kind of right below the root level constraint layout and before the recycler view, I'm going to paste in that text view and that progress bar. And if I then switch over to the design view, we can now see that we have that empty text and that progress bar within this layout. Now, if I come into the XML and I look at the empty text, this message isn't quite right here because on this screen we're viewing the weekly forecast. So instead of saying enter zip code to see current weather, I'm going to say enter zip code to see weekly forecast. So now I'm going to close out of the XML files. Now, if we go to current forecast fragment, we need to get references to these same views in weekly forecast fragment. So again, I'm going to do a copy for the new empty text and progress bar properties. I'm going to open up my weekly forecast fragment. And then at the top of onCreate, right after we call inflator.inflate, I'm going to paste in these new empty text and progress bar properties. And then very similarly to what we did in the current forecast fragment, I'm going to update the empty text and progress bar visibility in our forecast observer. So within weekly forecast fragment here, we want to find our weekly forecast observer. And then above the line where we call submit list and update our recycler view, I'm going to paste in these new lines. So when we get an updated forecast, we are going to hide the empty text and hide the progress bar. And then similarly, in the saved location observer, we want to make the same update to show the progress bar when we start calling load weekly forecast. So I'll add progress bar.visibility equals view.visible. So now that we've generally copied the same pattern that we're using in current forecast fragment, let's redeploy this to our emulator one more time. And now if I go to the week tab, we'll see there much more clearly that we saw the empty text with a loading screen, and then it updated to show our data. Now let's take a step back and walk through this full experience again. So I'm going to uninstall my app from the emulator. I'll jump back over to Android Studio, click redeploy. Now I'm back here in my app, and this is the first time user experience again. This is what we've been trying to improve. So now when the user installs the app for the first time, on the Today tab, they see this message, enter zip code to see current weather. If they switch to the Week tab, they see enter zip code to see weekly forecast. And then if we go ahead and enter in a zip code and click submit, we then see a progress indicator, and then finally the data loads. And we can notice that on either screen as we go between tabs. So this is a nice step towards improving that first-time user experience on both of our main tabs here in our home screen. And this is a really good idea, like I've said. You want that first screen in your app to not be empty and to give some guidance to users for how they should expect to use your application. Now that we've seen how to start adapting our UI to account for different logical states within our app, specifically an empty state and a loading state, I want to give you a brief overview of how you can start adapting to different types of screen sizes and configurations. As we've talked about in previous lectures in this course, Android devices come in a large variety of form factors. We have small phones, large phones, we have tablets, we have Chromebooks. All of these devices can be in portrait orientation or horizontal orientation. And if you start getting really advanced into Android development, you might start having to account for multiple windows or folding devices even. Now, thankfully, the Android resource system provides a really nice way of providing alternative resources for different form factors. So we can do things like provide an alternative layout for a horizontal phone, something that's in landscape mode, versus more of a vertical or portrait orientation. We can provide alternative layouts or alternative styles or dimensions for a tablet versus a small phone. All of these things can be leveraged to build user interfaces and user experiences that adapt really well to the specific device that your user is using at the time. So what we want to do here is update our current forecast fragment to look a little bit better on a large screen device, specifically a tablet. Now, to help us visualize what this looks like, we first need to create a new emulator. And if you have a computer with limited memory, you might want to close out any existing emulators that you already have open before creating and starting this new one. So as we've done before, to start a new emulator, I want to use the Android device manager. So if I look at the upper right side of the toolbar in my Android Studio, there should be a little device icon with an Android over it. And if I hover over that, I see AVD Manager. So I'm going to click that, and it's going to bring up this Android Virtual Device Manager. So I'm going to click the Create Virtual Device button. And then over on the left-hand side, under the category, I'm going to select Tablet. And then there's a few different types of tablets that we could select from here. I'm just going to go with the first one chosen here, which is the Pixel C tablet. I'm going to click Next. It's going to ask what system image I want to use. There's no need to download a new one here. I'm going to use Q, which is the one that's already defaulted here that I already have downloaded. I'm going to click Next. And then I'll just click Finish here to finish the creation of this new tablet emulator. So now I'm going to go ahead and run that emulator. So here we have the new Pixel C emulator on my device. And we'll see by default it is set here into landscape orientation. If I rotate the device by clicking the rotate icon in the emulator toolbar, we'll see that it will then rotate so that it's now in portrait mode. And if I scroll down from the settings, we'll see that auto rotate is off by default. If you go ahead and click auto rotate on, then we'll see as we rotate this emulator, the UI is going to rotate to adjust it. So I'm going to leave it here with auto rotate on in landscape orientation. And now I'm going to go to Android Studio, and then I'm just going to deploy my app to this new device. And I'm going to want to make sure that I have the right emulator selected. So I'm going to click the drop down here next to the play button, and I'm just going to make sure that I select my emulator. So for me, that is Pixel C API 29. Once I've selected that, I'll go ahead and click the Run App button. And because of the work we did previously, our empty state here is looking pretty good. And if we go over to the work we did previously, our empty state here is looking pretty good. And if we go over to the other tab, it looks pretty good there as well. And just for completeness, we could rotate this once more. And we'll see that in portrait mode, we're also looking good. So now let's see what happens when we actually load some data. We'll enter in a valid zip code here. We'll click Submit. And now we see that we have our data. And if we rotate that, we'll see again in portrait mode, it also has data. However, this doesn't really look very good. On a tablet, having the data presented in the upper left side of the screen really just leaves us with a ton of empty space here in our layout. It's not visually appealing. The text isn't as large as it could be to take advantage of the space. So we're going to work on improving this by providing a custom layout for a large screen device so that on phones, we'll still display the data in the upper left corner of the screen, But on tablets, we're going to present much larger text and we're going to center it in the screen so it just takes up more of the real estate we have to work with. So let's switch back over to Android Studio. And what we want to do here is open up your current forecast fragment. And then specifically, we want to open up the layout for current forecast fragment. So that is fragment current forecast.xml. And now if you come over to the left side of the screen here, in the project folder, you'll see that fragment current forecast is within the res/layout directory. This is the default directory for layouts. Now, how do we go about creating an alternative layout for large screen devices? Well, what we can do is create an alternative layout directory specifically for devices who have a smallest screen width of at least 600 dp. And if that sounds a little bit confusing, don't worry, we're going to walk through that right now. So again, in the project window, or it would look the same if you're in the Android window, we're going to click on the res directory here. Going to right click on that, go to new, and then I'm going to select Android Resource Directory. Once I've clicked Android Resource Directory, it's going to ask me what type of directory I want to create. If we look at the drop-down here, we could see we could create a directory for layout files, for menus, for navigation files, for transitions, values, etc. So we're going to select layout. And you'll see by default, it uses layout as the name. Now this list here, this is the interesting thing, available qualifiers. If we scroll through this list, you'll see things like locale, layout direction, screen height, smallest screen width, ratio, orientation, keyboard, touchscreen. These are all qualifiers that we can use to provide custom resources. So whether that is a layout, a string resource, a dimension resource, a color, we can customize those based on all these different qualifiers. And the way to use this pane is to highlight the qualifier that we want to use. So for us, I want to use smallest screen width. And by using smallest screen width, again, that lets us say, use this alternative layout for any device whose smallest screen width is at least some specified value. So with your qualifier selected, you can then click this little arrow here, and it will then highlight the right-hand side of this. So for me, I chose smallest screen width. And so now it's asking me, what is the smallest screen width that I want to use here? So I'm going to type 600. So you see the combination of smallest screen width, which is in the little middle panel here, with the value of 600. It's now updated our directory name up at the top. So now our directory name is layout-sw for smallest screen width, 600 dp, which accounts for the 600 screen width that we just specified. So I go ahead and hit OK. We'll now look at our resource directory, and we can see that we now have this new layout-sw600 directory. So now any layouts we put in here will be used for devices that match the criteria of a smallest screen width of 600 dp. And so to just quickly test this, what we're going to do is click on Fragment Current Forecast. I'm going to right click and select Copy. I'm going to right click on Layout-SW600dp. And I'm going to click Paste. And I'm just going to hit OK to copy that layout file into the new layout directory. And so now what we want to do is we want to update how our location name and temp text are displayed in this layout on large devices. So what I want to do is make this more centered. So I'm going to start by adjusting the horizontal bias. So again, I've selected location name here. In the attribute panel on the right-hand side, I'm going to grab the slider for horizontal bias, which is currently set at 0. And I'm going to drag that over to 50 so that it's in the middle of the screen. And then I'm going to add a bottom constraint so that it is constrained to the bottom of the screen here. Now, as soon as I do that, it has now updated the text here so that it is sitting more in the middle of the screen. Now, the next thing that I want to do here, I want to select the temperature, and I want to center that with the text, or with the location name text. So instead of aligning this to the parent, I'm going to align the right-hand side of this to the right side of the location name. And then again, I'm going to adjust the horizontal bias on this to be right in the middle at 50% so that it is centered with that text. And now I want to make the text of this a little bit bigger itself. So instead of a location 2, I'm going to select maybe a display 3, or maybe even a display 4 for the text appearance. And then I'm going to select the temperature text, and I'm going to just select maybe a display 1, or even if we wanted to go really big, we could select a display 2 here. So that's just making that text look a lot bigger. It's going to take more advantage of our screen space. And now just one last adjustment I made. Similarly to how the empty text isn't quite centered, it's actually at like the upper third. I want to do the same thing for this text. So I'm going to select the location name text view again, go to the attributes panel. I'm going to grab the vertical bias slider, and I'm just going to slide that up again until it gets to 33. So that it just sits kind of in that upper third, which again, just as far as design goes, I think generally it looks a little bit more balanced that way, kind of follows the rule of thirds in design. So let's test this out. Let's deploy this now to our emulator. So now with this new update, we see that this looks a whole lot better on our tablet. This feels like it's taking more advantage of the screen that we have on this large device. It feels like it wasn't an afterthought. It feels like we purposely designed it for this screen. And if we rotate that, again, in the horizontal mode here, it's looking pretty good as well. Now there's a lot more that you could do with this type of resource qualification. We could have special layouts for landscape. We could customize our list. There's a whole lot you could do. However, for this week, we're just going to keep it really simple and introduce you to this concept of qualifiers and keep it specific to current forecast fragment here.